Okay, good morning once again, and thank you so much for joining. So far, we have about 70 participants who have joined this meeting. And so I'd like to welcome everyone once again. And the session that we have at the moment is an introduction to STATA. And this is actually our fourth day of our Emerging and Established African Research Training Academy. So I do hope you have been gaining a lot so far. And today we're going to have quite a jam-packed session learning about STATA. I'm joined today by my colleague, Ms. Sisonke Mtiapi. Sisonke, do you want to say hello?
Hi, good morning, Inva. Good morning, everyone. I'll be the technical facilitator for this session. Thank you very much for joining. Let's meet in the chat. Thank you, Inva.
Thank you, Sisonke. Sisonke is also a senior researcher at the HSRC. We're joined by our presenter, who is Dr. Brian Mazarotse. And Dr. Brian, would you like to say hello? You're muted.
Okay, excellent. Yeah, good morning, everyone. I'm so excited to be here. I hope that this will be a very productive session. And I just wanted to find out if my camera is on from your side. Can
Yes.
everyone see me? Okay,
Yes.
excellent.
I can see you. I think we'll hear from our group if there are any issues, but I can see you fine. I can hear you fine. So we good.
Okay.
Perfect.
Excellent.
So Dr. Brian has some learning objectives for us today, and he will take us through the basic interface and functionalities of STATA. We'll also learn how to import, clean, and describe data within STATA. And we're hoping to also gain some practical skills in running basic statistical analysis and, importantly, interpreting the output. So once again, welcome. I hope everyone's ready to go. And before we do that, I think I would like to share a brief bio of our esteemed presenter, Dr. Brian. He's a senior lecturer in the Department of Accounting and Economics at Sol Plaatje University, which for those of us who are outside South Africa, that is in our Northern Cape province. So he's traveled very far to be with us today. And his PhD is in economics. He specializes in applied econometrics, labor markets, and developmental economics. And he focuses on policy-relevant research for sub-Saharan Africa. So welcome once again, Dr. Brian, and we look forward to your teaching. And colleagues, just to let you know, in terms of the format of our session today, we will try to end promptly at 1 o'clock, and there will be a break, about a 30-minute break in between, and we'll see how it goes, depending on how much progress we make. So thank you once again. Please feel free to post questions on the chat, and we'll try to tend to them promptly. And at the end of the session, we would also appreciate if you can fill out an evaluation form on the session. So with that, welcome once again, and over to you, Dr. Brian.
Thank you very much, Doc, for such an exciting and nice introduction. I think, colleagues, as a starting point, it's crucial that we get an understanding of where everyone is in terms of using STATA. So really the question that we've posted in the chat is very important, and would appreciate if maybe we could allocate the next 2 minutes to make sure that everyone really drops something in the chat. The reason why this is so crucial is this is a software package which can be, I know the title is introductory, but we would really appreciate if we could maybe meet each other halfway. I do see that some have been using STATA to some extent, and there might also be some who are seeing this software for the very first time. So I think it will be really useful if from the word go, we get an understanding of where everyone else, is in terms of using STATA and data analysis. Yeah, so I'll just wait for a minute or two. So far, majority of the responses seem to indicate that yeah, I've never used STATA before. I have no experience with STATA. I think I've seen one or two that have used this STATA in their publications. Yeah, so please keep typing in the chat for the next minute or so. We'll start at exactly 9:07. And as we are dropping in the chat, I think I would also want to indicate that I'm facilitating from the workshop. So please bear in mind here and there when the door opens, our students, I have indicated at the door that I'm facilitating a workshop, but we all know how our students behave. They read a notice, but they still want to try their chance. So I see everyone is responding, my experience. Okay, so I think it's fair to just generalize that majority of the participants have little to no experience with STATA. Okay, so that's very important. So what we will do, colleagues, is to start understanding what STATA is, what it does, understanding its basic features, what it can be used for, and so on and so on. So we'll try to start from a PowerPoint presentation perspective. So I will go through PowerPoint presentations to sort of give you that background understanding of the software and what it can do, and so on. Then after that, if we gain that understanding of the basic features of the software, we can then move to the practical aspect, which I think is more important. So at that stage, what we will be doing is to sort of, you might have seen that there is a data set that we'll be using for demonstration. It is 3 types of data sets. So we are going to try to illustrate some basic, how we do some basic analysis in STATA using different types of data sets, because I also know that when you're learning a software, we mustn't learn a software oblivious of the type of data that you are working on. Some of you are in the field that really overly use cross-sectional data. Maybe you're doing surveys and so on. Some of you might be using time series data. Some of you might be using panel data. So it's important that our demonstrations also accommodate that that aspect, that you might have different people using different types of data sets. So I have prepared the data sets accordingly to make sure that we take that into account. So that's what we are going to do. We will start demonstrating using cross-sectional data. So this will be very useful for those of you who are working on surveys. data that you normally collect at one point in time across maybe firms, households, countries, and so on. And in most cases, you collect that data with your questionnaires and so on. So that will be our starting point. We'll do graphing and so on and so on and so on. And then after that, we'll move on to time series. And then finally, we'll cover some aspects of panel data. Now, I will introduce these concepts from a very basic because it's introductory. But if you are someone who has been using STATA for some time and there's something that is maybe a little bit more advanced, I don't mind, you can drop in the chat. If there's something specific that you would want clarity on, you can drop in the chat. And Sisonge will let me know, or the chair. Yeah, Dr. Naidu will let me know if there's something that you need a bit more explanation at maybe an advanced level. You can drop in the chat. Then the second thing I wanted to indicate is I understand different presenters have different preferences in terms of how they interact with participants. I am one presenter who prefers the session to be as interactive as possible. So by that, I mean, feel free to interrupt me at any point. Just interrupt if you need something that maybe if there's something that I've said that you didn't quite get, or if there's something that you need further clarification or something to that effect, feel free, either drop in the chat and we will deal with it accordingly. Because I believe, the learning exercise is more effective if we are dealing with problems as they arise, rather than wait until 30 minutes and then ask a question that we would have covered 30 minutes prior. So that's what I think is important for me to mention from the start. Now, Dr. Naidu, may I ask if it is possible for me to share the PowerPoint slides on my side, or
Yes.
you can only share from that side? Can I?
Yes, Dr. Brian, please go ahead.
Okay. So let me try to share. I think it's much more effective to share the screen rather than the slides, right?
Sorry, to share
the screen rather than the PowerPoint slides themselves.
Share your screen. Thank you.
The screen, yeah. Okay. Okay, I'm doing that. Should be popping in a moment. Okay, please let me know once.
Yes, perfect.
Okay,
you can please put it in presentation mode.
Presentation mode.
Yes, at the bottom, there's a little screen. Okay. Thanks.
All right, let me do that, share. Okay. Is it in presentation mode now?
Yes, it's perfect. Thank you.
Okay, excellent. Okay, so we can start, colleagues. I'm looking forward to this. So these are the three main learning outcomes that I hope by the end of this session we would have achieved. So I would want us to have a basic understanding of the interface and the functionalities of the program itself. And once you get to understand its functionalities and the interface, by interface we mean, what you see when you open the software, what pops up, and what exactly would be in front of you. We'll try to define those sections, what sections do this, what sections do that, and so on. Then the next learning outcome would be how to perform, general importation of data, cleaning, describing data before you actually do the analysis. And obviously, the last one would be gaining the actual practical skills of, doing basic statistical analysis, as I indicated, using either cross-sectional, time series, or panel data. And we're going to go through all those. And as Dr. Naidu indicated, we will also allocate a great deal of time in terms of interpreting the output that we'll be seeing in front of the software, because I think it's equally important. I always tell my students that a software can give you any results. You can punch it a code and it will give you results. The question is, do you know what you are doing, and do you know how to interpret the output that you've been given? So we'll try to be doing that along the way. And one other thing that I would also want to indicate, I might have forgotten to indicate this from the word go, is you will see when it comes to demonstrations, I will try as well to deliberately get into errors so that you see the sort of how you deal with errors as they arise, because part of being a researcher is to deal with bugs, errors, coding mistakes, and so on. So here and there, I would deliberately make mistakes so that, and then I will explain to you what would have gone wrong and how to sort of get over it, because I think it's very, very important. I mean, the alternative is to just work on a perfect file and so on, but usually it's not effective, because once, especially for those of you who haven't used the software before, once you get an error message, usually it turns down someone who is new to the software, and they feel like they don't know how to proceed. So at every stage of the analysis, I'll try to play around with different aspects that can lead to errors and get over those errors before we proceed to the next. Okay, so as a starting point, and also let me know in terms of time, if you feel like I'm a little bit over time, just let me know, because I'm not looking at the time from my screen here. So let's start by understanding what STATA is. So STATA is the STATA. So STATA is STATA. That's what it is. It's not an abbreviation which stands for something. STATA is STATA. So it's a statistical package developed by a company that is based in the United States of America. So what it basically does in the main is it's quite useful for data management. You can save your data, you can manage your data, your databases. It also performs statistical analysis, and it also does graphics. And in terms of fields that it is applicable in economics, you find it in sociology, political science, epidemiology, and public health. Epidemiology, you might have seen, for those of you who are in this area, that it was quite prominent during the COVID-19 pandemic. A lot of researchers published their preliminary results about the efficacy of drugs as they arose at the time. Most of those findings were actually done by STATA. Yeah, so it's quite useful. And you will see when we get to the program itself that some of the models that you find there, they are more useful in other fields than others. And I'm sure I'll add more detail to that. So whether you're in health, you're dealing with disease, the spread of diseases, whether you're an economist, you're dealing with inflation, whether you are a criminologist, you're dealing with crime, whether you're a trade economist, you're dealing with export, tariffs data, whether you're a food economist. I mean, you will find this data very useful, even if you're in sociology. You will find it very, very useful. And we'll try to link these different fields at a basic level when we get to the software itself. Okay, so maybe before as well, I move to the next slide. STATA does a lot of things. For those of you who are in the field of economics, you might be familiar with the recent wave of dynamic stochastic equilibrium models, simulations, and all that. STATA can actually do those things for those of you that might have not known, because I've met students in different platforms seeking to learn, MATLAB, Python, and so on. And the primary reason that they always give me for attending those sessions is, for many years I've been using STATA, but now my supervisor wants me to run, a computable general equilibrium model or a DSGE model, and STATA does not do those things. So someone advised that I learn MATLAB. STATA can actually do a DSGE modeling, but of course it's an advanced, sort of way of analyzing data. I just thought it's necessary that I indicate it from the word go, that it does a lot of things that most people don't actually appreciate. So when you open the software, you are going to see 5 main things. Okay. So these 5 main things comprises, the first one would be what is called a command window. You will see it shortly after this slide. So what the command window does is it allows you to type your commands. A command is like an instruction that you would have to tell the program to do something. So there would be a command that you have to type in that command window to tell the software that what I need you to do now is to compute a pie chart, for example. What I want you to do now is to run a linear regression where this is the dependent variable, this is the independent variable, or I want you to run an analysis of variance. So that's primarily what the command window is about. Then the next one will be the results window. This will be sort of the big square box that you will see shortly. And that's sort of where you get to see the bulk of your results. I mean, your output. I mean, the results of what you would have typed in the command window, they will pop up in the results window. It's the biggest part of the screen that you will see. Then on your far left is something called a review window. So what a review window does is it shows, in other words, it stores or shows the history of everything that you would have done in terms of typing in that command window. So if we go back to the command window, maybe you instructed the program to run a linear regression. After that, maybe you plotted a scatter plot. Maybe after that, you computed a correlation matrix. So maybe you did 3 things in sequence. So that order will be maintained in the review window. Like if you go to the review window, everything that you are doing, that you are typing in the command window, it will be showing on the far left. And there are some reasons why that can be important, and I'll mention that when we get to the actual demonstration. But the most important aspect is you are able to see in real time what you are doing on the side. Even if you make a mistake, you will see how it shows you that you have made a mistake, and so on. Then the variables window would be on your right. So that's where you see all your variables after importing data from whether Excel or some other source. Then lastly is the properties window. The properties of window, the properties window, that's the section which sort of explains or describes the properties of your data that you would have imported in STATA. Then the last one that you see is not something that you see on the face of the software. It's called a do file editor. You would have to go somewhere to sort of see it pop up or do something. I'll show you how you do that. But basically what a do file editor in the main, what it does is, number one, it gives you an alternative way of instructing the software to do something, but by writing on a script. So it's a box that will open on the side, and it allows you to write it like a script, store those instructions maybe for future use, and you can rerun to replicate your results and so on. So it's something that pops up if you do something, and I will show you how it pops up. It's quite useful if you are a lecturer, you are lecturing a module that requires students maybe to do an assignment that is practical, and after doing that assignment, they're supposed to send you what they've done. A do file is very important because it will allow you as a lecturer, for example, to just take that script, that additional file, and look at all the instructions that the student would have written, and you can basically run all the commands at once, or you can select the ones that you are interested in. And if the students would have shared with you the dataset in DTA format, you should be able to replicate and see what the student saw or what they got when they were doing their assignment. So that's sort of what and how we do it when we are teaching these modules, where students have to actually go and work with data. Now, if you may be just a researcher and you're not a lecturer, you're just a researcher who is publishing results, you're publishing in journal articles. A do file allows you to store, it's like a way of storing and remembering what you've done. So if you are doing a survey analysis, you would know the first thing maybe that you need to do is to clean data, you manipulate data, you transform it into logarithms, you do all sorts of things that maybe you have to follow sequentially to ultimately get to the set of results that will be published by a journal. Now, the good thing here is, if you have that and you have the accompanying data set and you store it somewhere, even 10 years from now, as long as you have STATA, you will be able to replicate the results of an analysis that was published 25 years ago, 50 years ago. Now, that's a very good thing, because if you really follow that retraction watch, you would see how many papers gets published today. And after 30 years, maybe some reader from somewhere across the world, they read that paper, they follow the methodology, but for some reason, they are unable to replicate the results in that paper, which was published 30 years ago. And some, you might have not experienced this, but this actually happens in academia, that a reader might actually write to the editor-in-chief to say, I read this paper, I followed what the methodology is saying, but I cannot replicate the results that are found in this paper. Therefore, they are suspicious. There might have been some manipulation. The conclusions of this paper are not really supported by the results. There must have been something fishy in this paper. And obviously, the editors will try to get hold of the authors to say, there's been a concern that has been raised. Someone was interested in your paper. They followed what you said. They went to the data source that you said you downloaded the data. Maybe it's publicly available, but they cannot replicate your results. And if the editor is not satisfied, they can actually retract the paper that was published. And in some instance, there won't be any problem. It's just that you can't remember what you did 30 years ago. But if you have a do file, you can just go to that do file and see exactly what you did, or even share with the reader that this is the do file, this is the data set. And probably sometimes, at times it would be a minor problem that maybe the publicly available data was maybe changed or adjusted, or the measurement changed after some few years and so on. So the good thing is, if you have a do file in the publication, you really have to have it for that specific reason. People are able to replicate your work, and I think that's very important. Now, I'm not quite sure how big this picture is, but if you can see my cursor here, what you see at the middle here is that results box. So this is where everything that we instruct the software to do will get our results in this sort of square box that you see here. Now, if you take the information that is there I mean, it confirms the software, the name of the software, the company, the copyrights, as we indicated, STATA Corporation, which is based in the USA. And their website is also found here on this box. Then obviously this would be the serial number of the license. Obviously, I'm using the license by SPU. Just on the license, the software, it has three main editions. You have the multi-processing edition, you have the standard edition, and the basic edition. So depending on the volume of data, the number of variables you are dealing with, you might need to know the specific edition that you want. But I mean, suffice to say that the MP edition is the superior among those three. Superior in terms of the processing, superior in terms of the maximum number of observations that it can actually handle, the maximum number of variables that it can handle. I think as it stands, I stand to be corrected, but I think it can handle more than 1 billion observations. Actually, I think more than 10 billion observations. So the lower you go from the multi-processing edition to the standard edition to the basic edition, the less you get in terms of handling large volumes of data and more variables. Yeah, so that's what I think I needed to indicate there. Then on notes, you can, so I mean, you will see when we are actually using the softwares and not the PowerPoint presentation, you see that if we click all these blue elements, an additional box will pop somewhere, which will give us additional notes. And you see that it's written help, set max var if you want to change the maximum number of variables. Because even if, for example, the addition that you get has a default number of variables that it can handle, maybe 5,000, it will have a maximum. So if the maximum is 12,000, this option will allow you to sort of increase that default to match what you want and to fully maximize the handling capabilities of that software. And you also see update all and others. So if there's any update that has happened since you purchased the previous edition, clicking update all will be able to update everything. And when we get to this part, you also learn how you can install an external command into the program for use. So this is the first one where your results will show. All this stuff that you see will go up as you are inputting more instructions and you're getting more results. So everything that is written here will sort of go upwards and it will create this empty space for you to see your results. Then this sort of rectangle box that you see, which is written command in blue, okay, it's written command in white, but in a blue rectangle. Yeah, that's more more accurate. So just below it, that's the command box. So this is where you put instructions. You tell STATA that I want you to run a linear regression using a specific command. So basically, that's where you type if you want to use it. The alternative is to use a do file. We'll talk about that a little bit later. It will achieve exactly the same thing. So if you type something here, your results will pop up in the top. And then what you see on the left here, that's your command history. This is your command history. So that's where everything that you are typing in the command, getting your results, you see the list of the instructions popping here, following exactly the order that you want. It will be something that is editable, if I may use that term, editable in the sense that it allows you to delete something from your history here. And you see under what circumstances that might be useful for you. If I forget when I get there, someone can just remind me. Then on your far right here, this box under variables, that's where your variables will appear after importing. Right now, you don't see anything because there's no data here. So basically, that's where your variables will be. They'll be listed in rows going down here. And then obviously the fifth one will be your properties. So that's where you see things like your label, those additional properties of the variables that are appearing on top. So you see, these are the main 5 aspects or features that we learned here. So number 1, number 2, number 3, number 4, number 5. Okay. And then right on top here, you will see there are additional features that you can use. More or less something that you find in any other software, that there would be an additional platform where if you are not really good at coding and doing the programming, there's a section that makes life easier for you. So for STATA, it is this top part. So let's say you don't know the command for running a linear regression or for running an ANOVA, you can simply come right on top here on statistics. And once you click statistics, as you will see, it will show a whole lot of things that you can do in an analysis, from plotting distributions, from running regressions, different models in panel, cross-sectional, diagnostic checks, and so on. Almost everything that is available for statistical analysis, you would find it somewhere here. And for those advanced maybe methods that would have been developed after this edition, if they don't appear here, I will tell you how you can actually install it here using this command box. You can install something from an external source so that you can use that command in STATA if it is not included in the software by default. Okay, and then you see graphics if you want to do your graphics, data, editing files and saving and so on. Then you will also see there is a help section. I think it will make much more sense when we are now doing the actual demonstration, but that's basically a part which if you click, you are able to get help in terms of additional resources, STATA resources, commands, even STATA conferences. You see question and answers and so on. So it's quite useful. And right below statistics, you will see these 2 sort of small square boxes. One has this, I don't know what this is called, but you would know that medical doctors use this thing to, to sort of scan us or something like that. So basically, these 2 Excel spreadsheet-like boxes, what they do is they afford you an opportunity to view your data once you have imported it from somewhere. So once it is in STATA, these 2 boxes, either this one or this one, will allow you, if you just click it, it will open that Excel spreadsheet, or rather STATA spreadsheet, because it will be data now in STATA. The only difference is one of them is in browse mode. By browse mode, we mean, and it's particularly this one, the one that you see a pan-like looking feature. What this does is it allows you to get a view or a feel of your data in STATA spreadsheet without running the risk of editing anything or changing anything. So you won't be able to edit that data in the same way you would, in a way that you would do if your data is in a spreadsheet editable format where you can change 2 to 3, for example, or you can drop one variable, or you can drop one row and so on. If you click in the browse, you can only browse, you can only see what is there, you can only check, but you can't edit anything. So the first one, which is this one, or rather the other one, allows you to view the data and also edit if you want. You can edit if you want. So it will depend on what you want to do. Okay. Then what else? Okay. So I think that's just about it in terms of the interface. If there is anyone who wants to ask anything, you can indicate in the chat, and Sisonge will let me know because I'm not seeing the chat. All right.
All right.
So this, yes.
Hi, Dr. Brian. So there are a few technical challenges that colleagues are experiencing, but we have resolved that. So
All
we've
right.
created a text file from the
Okay.
do file. So
Okay.
those are unable to open Stata or don't have Stata, they can
Yeah.
follow the code using the text file.
Yeah.
And then Rachel has asked about, okay, let's mute. May I ask colleagues on the call if you have a question to either pose it on the chat or if you may raise your hand while we are open for questions, just so that we are organized.
Yeah.
Okay, so Dr. Brian, there's a question from Rachel regarding the ability of STATA to perform meta-analysis.
Yeah. Yeah. So in terms of meta-analysis, I think I wanted to capture this aspect, or can we pack it up until we get to that
Yes.
section where so first what I want to do, I wanted to, in terms of the arrangement, I wanted to first deal with things that Stata can do by default.
Right.
And then, yes, and then we will move on to certain additional things that Stata can do using add-in features, like you have to get it from somewhere and then install it. So that will be answered when we get to that part. If I don't remember when we get to that part, please do remind me in the chat. But the point when we get there would be STATA does almost everything that can be done in analysis, as long as the person who has developed that particular code or that particular feature or that particular instruction has made it available somewhere. So you can just get into the command box and install it, and you will be able to do that.
Great. So I will remind you. There's
Yes,
another question regarding
yeah,
the functionality of Stata.
yeah.
And the question was about, does Stata only operate using commands?
Okay. Okay, so let me see if I understand the question very well. By command, right? By command, we simply mean an instruction.
Yes, so
right?
I think
Yeah.
it is pertaining to the do file versus the menu. So, but I think
All right. Okay. No. Okay. So in that instance, I just wanted that clarity because from what you are seeing now, you see there's a command box there. So I just wanted to make sure that I understood the question. So the straight answer to the quick answer to your question is no. You don't always have to put an instruction. You don't always have to put a command, precisely for the reason that I indicated, which is you can come to the top here, and all of this will make much more sense when we are doing live, demonstration, because we'll experiment with the different ways of using Stata. So if you don't want to use commands and instructions, right, you can use this top part. You can make use of this top part. So if you click statistics, it will take you, you can navigate to something that you want to do. For example, if it is a linear regression, and you go there, you click linear regression, and something will pop up which will allow you to sort of customize it in a way. By customize, I mean select what is your dependent variable, for example. Just highlight your independent variable and do additional things that you might need to do there for that particular method you want to do. And then once you click OK, you will still see your results here. So you will see that in that instance, you wouldn't have typed a command. You wouldn't have gone to a do file to type something. But what you must know is, even if you go right to the top and use these statistics without typing anything, you will see that as soon as the STATA reports results here, it will automatically post a command that is equivalent to what you have done from the top. So it will appear on this history here as something that you have done. Yeah, so the straight answer is no, you don't always have to remember the codes. If that's where the question is going, you don't always have to remember the code, the instruction. You can also use this top part as long as you are aware of the method you want to do. You can achieve exactly the same output as someone who knows the code and they are able to type in a do file or in the command box. I hope that that answers the question.
Thanks so much. So we do have 2 hands. Are you happy to take those 2 hands?
Yes, yeah, I think it's more effective if we go that way.
So may I ask, I'm sorry, I don't know who put their hand up first, but may I ask Akosua to please unmute and ask your question?
Thank you, ma'am. Thank you, Doc, for the presentation. You can hear me?
Yes, I can hear you. Thank you very much.
Thank you very much. It's Dr. Abiola Akintunde from Maseru.
Yeah.
I'm a consultant, and this is a very good presentation. You have demystified most of the things that I am really worried about. This command code and everything can be written in words, and then it's going to be okay. I just want to know, like yesterday I was saying, SPSS and STATA are kind of similar, except that, but I was told that it's like STATA is kind of more specific and more complex. It's not as user-friendly as SPSS. Now, if I have my data, we do it with SPSS on the spreadsheet. Can I also import it onto STATA, like I do with other secondary data? Yeah, thanks.
Absolutely, yes. The short answer there is yes, you can do that. But can I also add something, Doc, from what you have said? You know, this question of, and I think I saw it in the chat before we started. I think there was a question that sort of asked which one is better between SPSS and STATA. Yeah, I think I read the question to that effect. You know what? This question, I think it's wrong to ask this question as a researcher. I don't think we need to ask it in that way to say which software is better between this and that. I think as a researcher, you have to understand what you want to do. I mean, that's the most important aspect. In the main, all statistical softwares, in the main, majority of the things that they do, I mean, they have some commonality. Like if you go to even the most sophisticated softwares, your R, your MATLAB, they still have a lot of things in common that Excel will do, that STATA will do, that SPSS will do. So I think it's important that we start from there. Then, obviously, there will be those softwares that are really, really designed to handle a specific aspect of maybe in a particular field, in addition to the basic things that other softwares can do. So this is the part where understanding what you want to do plays a very big part. Rather than coming from a perspective where you want to learn these two and what influences your decision is which one is easier to learn than the other. No, I think that's a wrong approach to understanding softwares. I think it's about understanding all of them. That's my recommendation. Not necessarily being an expert in all of them, but I think to just have an understanding of what SPSS does, what STATA does, how, and sometimes it's just a small matter of saying, I don't like the way, you know, SPSS graphs look like. I like the way you can customize a graph in STATA. There are still both pie charts, for example, there are still both line graphs, but you might find a software that has additional features to just make a graph more colorful, more presentable, and so on. So I think that's the spirit we must have as researchers, that which one presents, I know, is able to do what I want to do better than the other, rather than to say which one should I learn, which one is easier, and so on. STATA is not, I don't agree with anyone who says that STATA is more complex than SPSS. I totally disagree. And I think that that understanding might primarily come from someone who maybe thinks that there's only one way of doing data, like programming, coding, and so on. You will see when we start working with this data that it's so user-friendly. Like many of the things that people are scared of, they are so basic in data. Yeah, so we'll do both, and you'll be able to judge for yourself towards the end of the session. I hope I will be able to demystify this. It's not a complex. Some of the, and when it comes to instructions, you will see that some of the commands, some of the instructions, those routine instructions, I'm able to type them very fast. That should not discourage you from wanting to learn those things. Why? Because as a starting point, you don't always start proficient in programming using those instructions and so on. No, I was never proficient in using the command box, in using the do file when I started. You start with the basics. You start with the top part and follow exactly the default setup of the software. You get output. And then all those additional, understanding of the structure, they come with experience. And I'm sure many researchers who have been using STATA before in the chat will testify to this, that the more you use the software, the more some commands stick in your brain. Like you no longer see the need of you going up to click statistics and look for unit roots, for example, or something else. When you know in your head that, I can just type blah, 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 and then you click enter. So some of the things, they come over time as you are using the software more often. Yeah, that's just what I wanted to clarify. Yes,
excellent. Sorry if I can just say this 1 minute. Sorry for that. That is an extensive explanation. I like it. When you are publishing, most of the articles you write, you need a very good result and a very good convincing statistical analysis. So I think at the end of the day, what we just have to do is to try to invest more of our time in learning many of these things, which I've been trying to do. And I think people should try to do it. Like you are saying, they are doable, and we should endeavor to learn how to do them. We should invest our time in them. Thank you so much, Doc.
Yeah. Thanks very much.
Thank you. I'm sorry, Akusua, please go ahead.
Thank you, Imbarani, and good morning, Brian. I just wanted to find out if I take a do file from a different study and I upload it onto STATA because I want to replicate their research. Firstly, where does the do file display? Like once I open STATA, where would that do file display in terms of these 5 sections? And then secondly, do I have the option for STATA not to automatically run run the commands that are in the do file, or can I actually just display the do file and then I go step by step in terms of running each of the analysis without it just automatically doing everything at the same time?
Okay. So thank you for those questions. What is Akusua?
Yes,
okay, yeah. Akusua. So what I've done, Akusua, I've written your questions. The first one is, where does the do file shows up? And then the second one is about automation, like can you automatically, does it run? Can you stop it from automatically, and so on?
Yes.
Okay, so I want these questions. So what I don't want to answer this question now. You know why? The reason is, you will see when we are actually doing the live demo, maybe I might have not explained it well. So this is a presentation which is just meant to give you a preliminary feel of the software. We're not done here. I think we have about 28 slides to go. Then I'll actually open STATA, the program itself.
Okay.
And and you'll be able to see how, if you have a do file in your instance, I mean, in your question, the first question, if there's a do file that you downloaded from somewhere, you'll be able to see how it will show up in STATA. Like practically, you'll be able to see. And then the second aspect of whether you can stop the automation of everything that is there, it will be answered. You will see that.
Okay.
Yeah, but just
All right.
on the surface, just on the surface, it's nothing very complicated. It's nothing complicated at all. The second one about preventing STATA from running everything, you will see that even with a do file, you still have the power as a researcher to either, number one, run everything that is on that do file. You have that power, and you see what you only need to do. It's just a button that you click after highlighting everything. And then the other power is to select, to be specific in terms of specific things that you only want the software to run from that do file. You can do that.
Okay.
Yeah,
All right.
you.
Thank you.
It will make much more sense when we get there. Yeah. All
Okay.
right.
Thank you.
Thank you so much, Dr. Brian. I do not see any other hands.
Okay.
The other questions that have emerged from the chat are regarding how to clean data.
Yeah.
But I think you will cover that. So.
Yeah, I will cover. Yes, exactly. How to clean data. Yeah, I think most of these things. Most of these aspects, they are coming up because we haven't gotten to that part. I think they will become clearer as we do the stuff practical. Yeah. So data cleaning. Okay.
Thanks. I think we can proceed.
Yes. All right. So if there are no more questions, let me just in 30 seconds, re-explain this page. And the reason why I am doing this is shortly after this, in a few slides, there will be two questions that I would really want someone to answer those questions to see if they've understood. So the square box you see in the middle, that's your results section. That's where your results will show. Right below is a command file, a command box where you type instructions or you type commands so that the software can give you results. But remember, you can also come to the top part as if we illustrated and perform the same thing without having to type. In the same way, you can go to a do file and type in instructions in a do file without necessarily coming to the command box, and you still get the same output. Okay. Then on your left, your far left, this is where you see the history of your commands, and then your variables this side, and then their properties this side. Okay. So your command window, I think this is just a summarization of what we've done. For quick command execution, the do file allows you to save and run multiple commands. The review window useful for rerunning commands. The results window, you check output and error messages. You would remember when I started, I said that I will, in some instances, deliberately run into errors. Those errors will show in the results box. And one other thing that I would want to add is that for every error, it is a specific unique code that STATA will show you just below. And if you click that code, something will pop up, which will, if you don't know what has gone wrong, sometimes you can get guidance in terms of what that error message is primarily about, and you can fix it very quickly. And then we have the variables or the properties section where you get a summary of the dataset in memory. Okay, so the first question would be, where do you type commands in STATA? Okay, where do we type commands in STATA? I want to run a linear regression. Where do I type my command if I need to type a command? Okay, let's go. Anyone?
Command line.
Yeah, would it be the only part?
No.
Yeah, where else?
at the command window down there, blue color.
Yes, yeah. So the command window in that blue color, that's the answer, the first answer. I then ask the second question of saying, is this the only section where you type the command or you give STATA an instruction? Would it be correct to say is the only section that you can put an instruction?
No, it's not.
By way of typing. It's
Below
not.
the notes.
Yeah.
Below the notes window.
Yeah. By that you mean a do file?
Yes.
Excellent. Okay. That's excellent. Okay. And what would be the purpose of the review window? The review window here. What is the purpose of the review
It gives
window?
you the history of what you have done.
Excellent. Excellent.
Yeah.
Excellent. That's excellent. Okay, so this would be sort of a recap of what I think I covered in my earlier explanations about a do file. When I was explaining that if a lecturer, you might want to replicate what your students have done in an assignment. If you're a researcher, you might want to replicate what other scholars have done, and so on. So this is just a summary of that. Replicability, better error tracking, efficient for longer analysis. So efficient, the term, I mean, that's the point for efficient for longer analysis. You know, what this suggests is, if you are doing analysis, and I like someone who said, if you are writing a paper for your high impact factor journals and so on, for those of you who are still new to research, this might not really be an important aspect. But as you progress as a researcher and as you improve your research skills, you grow in the discipline, one thing that you will notice is publishers, in terms of their impact factors, I mean, you're a new researcher, you go to low-hanging fruits, journals that are not really particular about the contribution, the volume of results, and so on. You would find that most journals at an entry level, they're just interested in seeing whether you demonstrated an ability to tackle a problem in a scientific way and get to conclusions that can be supported by evidence. And usually for those journals, it's usually a simplified analysis. Maybe you just compute a correlation matrix, some few graphs, and a basic ordinary least squares regression, and your paper might be published, right? But you see that as you grow, and we all start from there anyway, majority of us start from there. But with time, as you gain more skills and you want to tap into these high impact journals, you see that one of the things that they demand is a paper that really has enough results, like findings that are really robust. So we use the word robust to say, I mean, these are results that are not arising due to chance. It's like an empirical regularity that you have proved in your paper. And you find that in order for you to do that, you really need to do a lot of things in your paper. Like it might not be enough to just have one set of results, like one table. It might be desk rejected by the editor for a simple reason that your results are not enough. They are not worth publishing in a journal. You didn't do enough. And so that doing enough will push you at some stage to really think through what you need to do. And sometimes it requires you to go table 1, table 2, maybe table 3, maybe table 4. And in these tables, up to maybe table 15, in these tables, you would be doing something different. Maybe you're testing the sensitivity of your results to check maybe if you change variable measurement, if you control for other factors, if you consider a different time period, if you alter the sampling, the sample size, those minor alterations, and you want to check whether your main finding is strong enough to withstand those, small changes to model specification. You will see that all those things that you will be changing, it will be a lot of instructions that you will have to put in STATA, either a lot of instructions or a lot of manual work that goes into going to that top part. You go to statistics and you edit something, you do this, you do that, you do that. Now, a do file is so important in this, in this instance, because as you're going through that whole chain of analysis, you know that the only thing that you need to do is to make sure that you type that, you save it somewhere. Next time you come, it's much easier. Like you can have 50 instructions and it's so efficient. Next time when you want to come and do the same thing, but maybe in a different paper, you want to follow the same procedure, you just go, and sometimes maybe all you need to change are variables and just minor tweaks here and there. You won't have to start again like someone who didn't have like a script that is saved somewhere that follows, the standard statistical analysis and sensitivity checks and so on. And it's quite useful as well if you're someone who is specialized in a particular discipline. Sometimes you are so focused in a narrow field where you're not really doing research that is far off from each other. So if you have something that is aligned and is narrow, is specialized, having a very long do file that you would have done maybe only once might be an efficient way of doing analysis, because you don't have to start typing everything from the word go. You just need to change maybe variables, maybe here and there, change another line, add one or two things, and you get a new set of results. And then the last one, I think it will also speak to what Akusua asked about how you open a do file. You see there are two ways of opening a do file. One is on your laptop. If you click on your control, and depending on the, what do you call it? Look at me now forgetting your keyboard. I mean, yeah. Some laptops it's 9, so control 9, some is control 8. It depends on your laptop, but control 8 or control 9, one of them, mine is control 9. It will pop up a do file on the corner, on the top corner. And then for me, 8 will show me the browse mode of the data, like that aspect which opens up so that you see your data without having, the risk of editing anything there. So 8 and 9 usually they allow you to do those two aspects. All right, so this would be an example of contents in a do file. You can type clear all when the do file opens. Clear all means you are clearing everything that is in the software. Like if there was a previous data that you were working on, clear all will erase everything and you are starting afresh. Then set more off. Okay, so set more off is just, by the way, these are just examples of what you can type in a do file. It's not like every time you're doing an analysis, you always have to do this. It's just an example of some of the things that you can do. Set more off, you might want to do this if you are doing some analysis that, if I come back to this part, remember I mentioned that if you put an instruction here, your results will show in this box, and it will sort of be going upwards. Everything will be going upwards. Now, there are some methods that I'm not sure if you're not familiar with this and you're new to research, don't worry about it. But if you're in the field of economics, for example, there are some estimators or algorithms that so after putting an instruction, before they give you the final results, there's a specific name of those estimators, like the maximum likelihood estimator. For those of you who know it, the maximum likelihood estimator, it has to go through several iterations before the model actually converges. So it might go up to even 1050 before it finally stops in this box and shows you the final results. Now the question then becomes, in getting to that 1,500, what is happening? There are two things that might happen. One might be that it might iterate up to number 200, and then the computer will stop without giving you the final results, and it will require you to click more so that you tell it again to continue running. So that can be quite cumbersome, especially if the model will finally give you results after several iterations, because that would mean you constantly have to wait until it stops, and then you ask it to continue until it gets to results. So what set more off does is it takes away that burden from you. You don't have to, click again to tell the software to continue running until it gives you results. It allows the software to just run and continue running, continue iterations and all those things up until it stops on the final set of results. Yeah. Then this one would be if you are importing your data, and clear would clear everything that was in the software before. So dataset here would be the name of your file. Okay, so if your file, the dataset was called Brian, so it will be used brian.dta. So DTA is the format of your file if you save it in STATA. So it will be written DTA. I mean, that's the extension of your file. Then summarize, you would know that if you want summary statistics, you will see when we get there, if you want your mean, your measures of central tendency, standard deviation, min, max, and so on. That's sort of a command that you use. And then this last aspect, Akusua would remember that. So this last aspect is not necessarily an instruction that you have to put in a do file, but it's just an additional note to tell you exactly what I've asked, that you can run selected lines in a do file, or you can run the entire file. It's up to you. It's literally up to you. You can select what you want between these two. So I think this was a set of questions. I think they are much clearer to everyone. Clear all, it erases everything. Set more off is useful in scripts because you don't have to keep on telling the software to continue show the results until you get to the final set of results. And then what is the file extension for a do file? So I did not indicate that. The only one that I indicated is this extension for your dataset is DTA. So for the do file, once you save it, it will have a .do. So it will be .do. That will be the extension. That's how you see that this is a do file. And then supported formats, you have DTA, you have CSV. So these are formats that you can import. XLSX, which is your normal Excel, but for this demonstration, I think I will use DTA. I will use DTA. So far, you have the Excel version, but I will quickly do that as we are doing the demonstrations. I'll use DTA as well. Yeah. So this is just, again, an example of how you can import data using instructions, but all this will come clearer when we are doing it manually, practically. And then after importing a data set from Excel, let me just check my time. Okay, 13 past, I think about 10:30, we must be done with the presentation so that after the tea break, we'll work with the actual data. So once you import your data set from Excel, you can view it using browse. Now, this browse that you see here, it is the equivalent. It is the equivalent of clicking this browse mode. Remember, I said there are two tables that allow you to see data in sort of a spreadsheet format, but one allows you to edit, the other one doesn't. So if you, the other way of clicking this in browse mode is to simply come to the command box and type browse. It will do the same thing as someone who just went with the cursor and they clicked here. It will achieve exactly the same thing. And then list, we will list everything that is in the software from your observations, your variables, everything that you would have put. Just typing list will show everything. Where does it show everything? In the results box, that big square box. And sometimes you might want to identify how many observations do you have, how many variables are present. Usually it is at this stage that you're able to pick up some of those some of those things, because when you're doing an analysis, I mean, I would argue that this is the most critical stage of really, especially for those that are working with survey data. You really want to make sure that you know, your sample size is really reflected in the, you know, observations that you have in STATA. Sometimes you might be able to pick a difference between the number of observations which STATA is showing you vis-a-vis what you were seeing in Excel, or vis-a-vis the number of the questionnaires that you captured. So you might get an early warning at this stage that you might have had a capturing problem right at this stage in terms of the number of observations and the numbers of variables. Okay, and then we'll do data cleaning. Someone asked about data cleaning. I will show you how to achieve that, how to rename an old variable into a new variable, or to generate a new variable, or to drop, you know, if in cases where you have missing observations and you want to delete cells that are missing, we'll also cover that. And yeah, as I indicated, generating a new variable. So when it comes to generating a new variable, I would tell you, so gen would be something that you need to first type in the command box as a shortcut for generate. New var, so the new var would be the new variable that you want to appear in the software. Remember, if you're generating a new variable, you are basically saying this variable as it stands in STATA in my data set, it doesn't exist. So it's a new variable. So you have to find a name to call it. So this is what you write on the left-hand side of this equation. And then you put an equal sign where you see expression. That's exactly what defines what or how that new variable is constructed. And it depends exactly with the context that you are doing. I'll just give maybe one or two or three examples. One could be maybe you want to generate a new variable, but this new variable is basically the log of income. Like you have income in your questionnaire, you were asking people how much do you earn, and they were telling you maybe 25,000, 15,000. And now for your analysis, maybe the theory that you want to test requires your income to be in log format, logarithm. So you would have to generate a new variable that is basically the log of income. So you can then say gen, for example, log income equals to then log, and then this is where you put the expression, and you will see what that expression would be. It will be log, open, and then you put the actual variable that you want to transform into logarithms, and then you close bracket. So that's basically the expression. Sometimes your new variable might require an expression which is a power. Maybe you want to square a variable like x to the power 2 or h to the power 2. So your expression would be h, and then you raise it to the power 2. And yeah, that's then. Or just on this one, gen, I said it's a shortcut for generate, like a generating something. What STATA does, and you see when you get there, what STATA does is in its directory, like in its memory, there are some default commands that are written. Okay, so all commands are written in full, like they are programmed in full, generate. But what STATA does is it allows you to, I hope I will be able to explain this in a way that you understand. So if the full name is generate, STATA will allow you to achieve the same thing if you, for example, rather than typing gen, you write generate. So if I was to say generate here rather than gen, I will still be able to get the same outcome. In the same way, if I had, instead of write generate with GENERATE, if I remove the last E and have generate with only a T at the end, I'll still get the same outcome. If I remove TE, I'll still get the same outcome, ETE. So basically what I'm saying is STATA will allow you to remove a letter on the command that is inputted in STATA, write down up to that stage where that command cannot go beyond that, because otherwise it will now confuse it with something else that is like that in the software. Then that's when it will stop running. So gen here means we can't go below gen, but we can put another E here, like gene, and it would know that you are going to generate, because there is no any other command in STATA that will confuse gen and that which is not about generating a new variable, if that makes sense. It's the same way when we come to regression. You can type regress, but you can remove those two double S's at the end. You can remove them and say regr, and it will run a regression, because that regr doesn't execute anything else in that in the software that is not regression. Yeah, so you'll be able to see how we can reduce the number. We can remove every letter until we get to the smallest number, to the smallest number of letters. That beyond that we can't, because maybe there are 2 or 3 other things that exactly have those same characters, and it will not know what you want to do. Okay. Then labeling, we will also do variable labeling, particularly for those of you who are doing surveys. You might find that in your questionnaire, you have categorical variables like maybe your gender, maybe religion, maybe location, where you were coding 1 implying maybe male, maybe 2 female, or if it is level of education, maybe 0 is no schooling, 1 is primary, 2 maybe secondary. If you have done some survey analysis, you would have some knowledge about this. So you would have imported data with only numbers. So people would have ticked 1 or ticked 2 and so on. So when it comes to STATA, you would need to label so that the software, it becomes easier for you and the software to know what 1 is. Okay, what 2 is on that categorical variable, what 3 is it marital status, is it married, widowed, and so on. You'll be able to do that. So we'll do that labeling using a command, but also using the easier route of using that top section. Okay. And you can remove all rows with missing age, create a dummy variable for male, as I've indicated. A dummy variable, for those of you who are not familiar with quantitative analysis, it's an indicator variable, like something is there or it's not there. You are either staying in a rural area or you are staying in an urban area, and you might want to say, okay, it's 1 if you're staying in an urban area, 0 if you are otherwise. That's a dummy variable. So it's not something that is continuous. It's unlike your age, your income, and so on. It's a variable that takes 2 values, either 0 and 1 or 1 or 2. And you see how we treat such variables in STATA. Okay, so what does gen command do? It generates in the, yeah. Yes, please go on.
Yeah, so I wanted to ask, does STATA allow then for one to be able to generate their own commands and then give the function like you can do with programming?
Wow, excellent. Yes, it can allow you to do that. I always tell my students that they must always strive to get there. Like when you are a researcher, usually most of us, we are applied researchers. So we use methods that have been developed elsewhere, usually in the advanced countries, right? Something that is developed and we just use that command as it comes. But is it actually possible and it's doable if you have enough programming background? It's actually possible for you to go to Google Scholar or ResearchGate and then you see a paper, because this is what happens. There's a paper and it's a groundbreaking paper on a particular methodology, right? And that methodology, maybe it's a new estimator, and what those authors, maybe professors or some PhD students somewhere in California or in Ghana somewhere, what they've done is they've applied their knowledge of statistics and mathematics, and they have written down a set of equations that are able to maybe get to your results, if it is regression, for example. So if you download their paper, you don't find a command. but rather you get a conceptual understanding of what this algorithm, what this method is all about and how it should work in real world. Like if you want to actually analyze data, this is exactly the steps mathematically that these authors are suggesting, right? And then if that journal becomes acceptable, it's out there, there is nothing wrong with you or anyone else studying that paper carefully, those equations, and use their programming skills to develop a command that can then be installed in STATA to exactly do and follow in the background those steps that are available in that paper. That's exactly what happens in research. So you would find that there are some researchers who are not applied researchers. They are primarily there to develop codes for models. So you would hear someone says, no, so and so developed a method which addresses this, is very good because if you have maybe cross-sectional dependency, your models won't be, I mean, your results won't be reliable. And therefore they proposed a new modeling approach which does A, B, C, D, and F. But as it stands, no software actually has the ability to implement that method because it's something that is new. So you would need someone to develop a code that if it is installed in a particular software, whether it's ARA, whether it's STATA, it is able to follow exactly those steps in a paper and give you results. And the people will credit you for that. Actually, you will see when we get to that part, I think it's not Akusua, but there's someone who asked about something that meta-analysis. Yeah, meta-analysis. Yeah. When I said there are some additional things that you can install from an external source into STATA to then allow everyone else who had purchased this data before that new program was developed to then use it in STATA. Yeah, if you remember that section, it actually speaks to this part. So you develop something, you might either want to communicate with the STATA directly so that in their next edition, they will put it right in their directory, or you might want to put it somewhere on your website so that, you know, if there are students who would want to use that command, they will just get into the command box and install it from your server, I mean, from your website. Yeah, so it's 100% possible for you to develop a code of something and install it in STATA if you are good enough to do that. Yeah.
Thanks, Doc. We have a question from Kenneth here. Please unmute. Kenneth, please ask your question.
Okay. Can you hear me now?
Yes, Kenneth.
Okay, good morning. I want to ask, if you want to import a file with a command, are you required to set a working directory for your file, or just by typing the name, just by typing the command and the name of the file, I mean, STATA can import it from anywhere in your computer?
Yeah, you need to set the short answer. You need to set the directory. It has to know where it is going to find it. Yeah.
Okay, thank you.
Yeah. This is one part where STATA really does what every other software, whether it's ARA and so on, does. It has to track a pathway to get to where the data is located in your laptop. But you also see that if you are unable to work on and usually you do that either in your do file or on the command box. If you don't want all that, or if you're not very good at that, if you are very new to STATA, I'm going to show you an easy way of getting around this. You will see it's a very easy trick. You just do it once and you'll be good to go. You'll see. But basically, it's just you importing it using that top file, and then you import it like you're doing it sort of manually, half manually. And then once your data has been imported, like I indicated, the STATA will show the equivalence of that in a command, in that history of commands. So you can literally copy that, and that basically tells you exactly the directory. If next time you want to use what is it, a do file or the command box, yeah. If you're not good at directing it to where it is, you just need to store it somewhere and do it manually the first time, and then you know the code where your data set is. Okay.
Thanks, Doc. We're at 10:29.
Yeah.
And I know we said that we would have a tea break.
Yeah.
I wanted to ask about
Yes.
perhaps if you can comment around typing in capital letters or small letters. So the case sensitivity issue with STATA before we go on break.
Yeah. It's very sensitive.
Yes.
Yeah, you need to be case sensitive when it comes to typing commands. It's quite sensitive.
Thank you. Are you fine to take a tea break now?
Yeah, okay. Can I just 1 minute, just quickly see so that when we come from the tea break, everyone will have an understanding of what we will be doing
Yes.
in a minute. Yeah, so after this, okay, so there's Jen and E-Jen. Let me see if there's anything that, okay, this is what we'll do, summarize, tabulate. Tabulate. Okay, summarize, categorical variables, frequency tables, and interpretation and so on. Yeah, so you will see that much of the interpretation which we said we emphasize on will be covered when we're doing things in practice, interpreting coefficients, probability values, graphs, statistical significance, R-squared measures of goodness of fit, and so on, a do file. Okay, yeah, no, perfect. I think we can break for now, and then when we come back, we will be working on an actual data set after 30 minutes.
Thanks, Doc. Colleagues, so it's 10:31 and we have a 29-minute tea break, so we'll return promptly at 11 o'clock to allow Dr. Brian sufficient time to take us through part 2. Thanks so much. We'll see you soon.
Okay, thank you. Yes, sure, Dr. Naidu. Yeah, we can go ahead now. So let me share my screen. Okay, may you confirm, Doc, if you can see my screen?
I'm seeing a calendar, so if you have
that calendar, I think that's the screen so far. I think this files.
Okay.
But let me see. It's hidden. I don't want it to appear this way.
Yes, so we can see there was a graph that appeared briefly.
Yeah. No, let me see. I think I chose the wrong option of sharing. Let me try again.
Okay.
Okay, so colleagues, as I am trying to share, welcome back. So what we are going to be doing now is to sort of do the actual illustrations in STATA. Okay. Okay. I wanted to share everything. Yeah. Can you see my desktop now, Doc?
Yes.
Okay. Excellent. Okay. So, colleagues, what we are going to do is to sort of go through the demonstration. If you have STATA, you can work on that do file. You can be following along if that is possible. If you don't have STATA, I'll try to sort of adjust my pace in a way that maybe you're able to write notes. If there's something that you need to jot down, And if I'm too fast, please feel free to raise a hand because there's quite a lot of things that we might have to demonstrate. All right, so right at the bottom here, so I do have two STATA versions. So this one is 14, this one is 17. So I'm going to be using 17. Now, I indicated, I think one of the requirements was to have at least an edition from 2014 upwards. And you might ask yourself why that matters. So in some cases, if you're using STATA, in some cases, you might want to use an externally installed command. I think someone asked about generating new codes, and part of my explanation was that it's actually possible to install a new code from somewhere, from some source if it is available. And I will demonstrate that. So the reason why it's important to emphasize that, you know, the version, the STATA version, 14 means it's a 2014 version. The reason why it's important is.
Sorry, Doc, we're still seeing your desktop.
Yeah. I haven't moved.
Okay, great. Thanks.
Yes, I haven't moved, Doc. Thanks for that. Yeah, I just wanted to explain that before I click the actual STATA. So there are some cases where you have a command that does something, but what it does, that I'm saying something because I mean there's a whole lot of commands that do several things. It could be meta-analysis, it could be spatial analysis. There are some commands that are only compatible with earlier versions or latest editions. So very outdated versions like your 11, STATA 11, 12 might not handle that program. So that's the only part where this is actually relevant. So I'm going to click it, so just click it, and then it opens, and I'm sure you see this familiar screen which you saw in our PowerPoint slides. Now, let's start with importing data. So if you are importing data, there are, I would say, 1, 2, 3. There are 3 ways, at least, of doing so in STATA. At least three of them. So one is, let me see if I can get rid of this tab here. Or can I get rid of it? Can I get rid of this? Yeah, thank you. Okay, so there is at least 3, right? So I want to start with the most, I would say the easiest one, like the easiest one. So the easiest one is to copy paste, right? So you go to where your data is. In this instance, it's in my downloads. So you open your Excel. And by the way, I will start with cross-sectional data, and I would presume that everyone is aware what cross-sectional data is. Data that has been collected at one point in time across individuals. So in this example, as you can see, this would be data collected at a particular point in time across these individuals. Jane, James, Susan, it could be households, it could be firms. Okay. So what you can, there are 2 ways. One is to just copy. STATA allows you to do that. Like you can copy, I'm just copying a part of the data. If you copy it and you come to STATA. So remember we said there are 2 data editors. I don't know if there is anyone who still remembers the distinction between these 2. This one basically does not allow us to edit anything if we click it. And then so you can click this one which allows you to edit. And then you come to this first box which you see here. If you would like, I don't know whether it's the first column, if you exclude this dark gray or light gray, the first column, first row, you right click Have I copied? Okay. So you can come and paste here, and then some box will pop up. What this box is asking you is, what is the first row? Okay, what is the first row? So given that what we have done is our first row contains the variable names, for example, so we have to click variable names. Otherwise, if we don't do that, everything will be treated like a string variable. It will turn red. So let's do it the right way, and we'll do it the wrong way. Okay, so the right way is you click variables and names. So what we would have done is to just tell the software that the first row should be the names of the variables. So this is one way. So I'm going to cancel it. And by the way, you can cancel using this X that you see here without the risk of you closing the software. Okay, you can do that. So you can close here, and it will take you back to the main user face without losing anything. So now I want to demonstrate again pasting, but sort of doing the wrong way, right? I don't know if there is anyone who still remembers what I would have to do here if I need to remove everything that is in the software now, because I need to illustrate something. If you remember the command, the instruction that you type, no one, okay. Clear. So once you type clear in the command box, as I have done, you see everything is gone, okay. So let me go back again and try to illustrate that problem again. So this time around, let me click data instead of variable names, and you see what you see. So first thing, seeing red stuff means is the program is not really decoding that as your numerical observations. You are not at the same page with the software. So you can't proceed with any analysis in this instance. And you can see, if you remember, if I cancel this and go back to STATA, you will see one thing that has changed here is that in the previous instance where we correctly pasted and we told the software that the first row should be variable names, we actually saw the actual variable names here, the proper variable names. This time around, it says var1, v2, v3, v4, which is the default way of the program. If you paste the data that is not named, okay, it will automatically call them, numerically var1, var2, var3, var4, and so on and so on. But this is usually a sign that you did things wrongly. So you go back. So red is not a good color in the software. Red is not a good color. Now, you will notice that what I've done here is I clicked this data editor. Let's see what will happen if I click the data editor browse. So if I do that, I don't know if you can hear the sound from your side, but it gives that I'm trying to edit. It won't edit because it's in browse mode. Okay. This is because I didn't use this. I use this. So if I use the edit one, you can clearly see it's written data editor edit. With this one, you are able to play around with the numbers. You can change them. You can change anything here. I hope everyone can see that. Remember, I'm still editing wrong stuff in the sense that I have not properly imported data, but I just want to illustrate that you can edit if you use the data edited option. Now, I want you to then also see something. These additions that I have, these adjustments that I have done here, if I return back to the software, you will see that there has been something that has been popping up on the results window. So these are the results of what I've been doing there, okay? And you also see in your command history here that basically what I was doing, so what I was doing, just randomly changing those numbers, it will be the equivalent of someone who used this in the command box, this one. So it will be the equivalent of someone who entered this instruction. You achieve the same objective in STATA. In the same way, it would be equivalent to someone who goes to a do file and paste this instruction. You will get the same output. Okay. So we'll demonstrate that more when we get to the do. So this is bad. I'm going to delete it again and redo it properly. Okay. So I think now we have demonstrated how to paste. And obviously this will depend on the size of your data set. Sometimes it's so impossible because, I mean, the size of your data set in Excel is so big for you to be scrolling down and copying everything and so on. But that's usually the easiest way of doing that. The second one is for you to come and use this option. So you come right at the top, on your left, you click File. So if you click File, you see this will show up. You come to Import, and then you see all those different formats that are supported that you can use, different formats. If you remember from our presentation, CSV was also there and all those, so these are supported. So ours in this instance is this one. So you click Excel spreadsheet, and then this box will pop up. So once it pops up, you go to Browse. Basically, Browse allows you to go to exactly locate where your data is stored. Okay. And if I click it, I know that mine is in downloads. Okay, so this is the one that I want. But if it was anywhere in music, in videos, where econometrics, slides, where else, you'd have to come and look for it where it is. So mine is in downloads. So what I will need to do is to just click it and open it. Now, once this shows, so remember that when we used the method of pasting, there was that small square box that popped up, which asked us to sort of tell the software whether the first row are variable names or not. The equivalence of doing that in this instance is to come and click this box. You have to check this box. So you see that once I check this box, these names, the names of the variables here, they will jump one step up, so they will occupy this space where they C, D, E, F, G, which is a good thing. Otherwise, if I was to proceed without doing that, I will face the same error which I faced in the second example where I pasted and I did not tell the STATA that the first row should be variable names. It will be the same mistake, the same error. Okay, so once I check it, you see the variable names go a step up. Then another data, I mean, the section which is important is this worksheet. So this worksheet, what this is if I come back to my Excel, if you come back to your data set, it's important in cases where you have different sheets here on your Excel. For example, here, the first one is cross-sectional, the second one is time series, the third one is panel data. So, and remember, this is saved on one Excel document, sort of. So it's one Excel, but with different sheets, right? Spreadsheets. So what you then do here is to just click this arrow that is pointing downwards, and you will see the different sheets that your Excel has. So if we wanted to use time series here, I'll click this and you see the data will change here. It will take the sheet with time series. If we wanted panel, we'll click panel and the panel data set will appear. But we are starting with cross-sectional, so we'll check the cross-sectional one. Then once you're done, that's it, you click OK. So once you've done this, you will see that in the results section, you have this new sort of instruction which shows up in the output section. So if I come back to What this means is we have done something without typing an instruction, but our output, literally what it means, our output, and if I remember, someone asked about understanding the directory and so on. Our output literally is, I think someone is raising a hand. Yeah, you can go on before we proceed.
Okay, I lost connection, so can I please have the link for the data set?
Oh, okay.
Okay, we will tend to that. Doc, please continue.
All right. Okay. So what I wanted to indicate was you basically see, particularly to someone who asked about knowing the directory. If you check in the output box, you will see this one. This literally tells you the path that the computer had to follow to get the data set. So it's in C, in users, admin, in downloads, and the name of the dataset is demonstration data, and this is the extension, and then under sheet is the first sheet, which is cross-sectional data, right? That's essentially the point I wanted to drive home. So what it also means, remember we said you can do these things in several ways. That's the good thing with this data. You just master the one that you're okay with, and you can go with it. Alternatively, what you would have done is, if I copy this one, which by the way, is also appearing in this history here. So if I click here or copy it from here, it will come down here on the command box. So if I click it here, you see that it appears in the command box here. So literally, I hope everyone can see that what we have done by coming to file and adjust that box, select the sheet, it will be equivalent to someone who is good at programming and they just type this instruction, import space, Excel space, and so on, until you get to the last one, which is first row. You will import your data. In the same way, again, someone would have copied that entire spreadsheet and pasted it here. It will achieve the same thing. So let me just demonstrate that. So I'm cutting this. And what I'm doing is, by the way, I hope you can see that the variables are now appearing here. And if I click here, I'm able to see that my data has been captured correctly. The red names here is not a problem because the string variable, these are names of individuals. So you shouldn't worry. And as much as I say the red is not a good sign, but this one is fine because they're individuals. Okay, this is the most important part. So if I clear everything, like if I want to start again from where to go, and I know this instruction, I would simply type it here, but because of time, I will just paste it here. If I go back here, you see there's no data, there's nothing here. But if I paste this and enter, you will see that the data has been imported. And if I go back here, you see that the data has been imported from Excel. So it emphasizes the point that I mentioned earlier, that there's so many ways of doing one thing in this data, and it's about which one are you comfortable with, and maybe where are you in terms of research. So it's always advisable to start with the easier one. The one of typing the instruction, you see that it's long, it's sensitive to how you put the slashes, the spacing, and so on. So if you're a little bit unfamiliar with that, it's much easier to do things following what the program is, how it is designed. You come to file, you import, you look at the version, the format, and then you look for where it is under browse, you click it, and you make sure that the first row is a variable names, and then once you are good to go, okay, so this is because I already have. So it's a warning to tell you if you saw what happened. It's a warning to say you want to override something that is there. Okay, so if you say yes, it will override. It's to warn you before you override what you already have. Yeah, but the point I wanted to mention is it's always advisable to start with this. And maybe you can then copy these instructions either from this history section and store them somewhere, maybe in a do file separately, so that in future you can then learn how to type the same command and start to work with the command box. With experience, you'll be able to know that. Okay. I'm just going to, yes.
There is a hand from Bertrand.
Yes. Yes. Yeah, go on.
Just a quick question, Doc. I just wanted to find out. I see when you try to import the Excel file or something you showed us there, where you have the cross-sectional data, panel data, and time series data. Now,
Yes.
the question is, if is it that the software automatically detects what available data you have, or is that the standard those three types of data are the standard formats in which data is? Yeah.
Okay, that's a good question. That's a good question. And if I hear you correct, I will answer it this way. And feel free to raise your hand again if I didn't really understand what you're asking. But I think I get what you're saying. If I hear you well, you are saying if I click File, Import, and Excel, then I click the data. Where is it? Demonstration data. You are asking here, is the software which detects whether it's cross-sectional time series of panel, right?
Yes. So is that automatic, or it is you who has to assign that, and then does it automatically detect that, or?
Yeah. So it's a very good question. So no, what has happened is, if you get to that section, the software will detect these spreadsheets exactly the way you named it yourself as the researcher. Yeah. Okay. So it's yes, sure. Yeah. So if I for example here changed it to cross-sectional data HSRC, or even even just say HSRC, as long as you know it's cross-sectional data, and if I save it like this and go to STATA, you see that the first sheet will pick it the way it is appearing there. I hope I saved it. Yeah, you see here, HSRC. So the first sheet is HSRC. So it's just about you as a researcher, how you named those spreadsheets in Excel. And they don't always have to be cross-sectional time series and panel. It depends on what you want to do as a researcher. Sometimes you group your spreadsheets by maybe the different data sets. Maybe it might be all of them, they are cross-sectional, but they are different samples. Maybe this is one sample from Gauteng, the other sample, which is another spreadsheet, is from Free State, the other spreadsheet is from KwaZulu-Natal. If you come here, you will see Gauteng, KwaZulu-Natal, Free State, Northern Cape, and so on. So it's about how you name them in Excel, not that a software automatically says it's cross-sectional and so on. I hope I managed to answer you.
Yes, you did, Doc. Thanks a lot.
Yeah. Okay. Okay. All right. Let me try to remember what I was explaining. Which part was I now? Okay, I think I was.
Sorry. Hello.
Yes.
Good morning.
Yes,
Sorry,
good
I
morning.
just have a question I want to ask.
Okay.
Does based on what you showed us right now, importing files, you can only work with one worksheet at a time. It's not possible to work with multiple in case you have like an analysis that runs across different sheets.
So if I understand what you're saying, would it be equivalent to asking if you can run multiple analyses in STATA at the same time with different data sets at the same time?
Yeah, they might be in the same workbook, like for different sheets. Yes.
Unfortunately, no, because that's why you saw when I tried to import again, it will ask you to first clear or override what is already in STATA. Yeah, what is already in STATA. But what you can do, if I hear you very well, if you have different sheets that you have, you would rather have separate do files. You can open 3 or 4 do files. And then what you can then do is to just alter, you change the data set, you put STATA, and then you work on a different do file. that is very possible. So each do file will be specific to a spreadsheet. Otherwise, to put different data sets at the same time, I'm afraid it's impossible. You would have to override what you have here.
Okay,
Yeah.
so if I understand what you are saying is that I can, in order to run such an analysis, I can create do files for each of the sheets and treat it as separate files.
Yes,
Is that what you're saying?
yes,
Okay.
yes, yeah. You
But
can
I
actually
can't run
save. Yeah. You can save different do files that are consistent with your different, spreadsheets. And so the only thing that you will need to vary there is to make sure that when you are using a particular do file, you have the right data set, you have the right spreadsheet in STATA, in Excel, or in STATA rather. Yeah.
Okay.
Yeah. Okay. I don't know if I can proceed or there are more hands. Okay, can we proceed? Can I just have a confirmation?
Doc,
Can we proceed?
I'm raising my hand. I don't know if I can speak.
Okay. Yeah, please go on.
Yeah, when you are looking at the type of data cross-sectional panel and so on, is it right to say the panel data is like the old data in the Excel, everything, while the other ones are just sections part of the old documents? Am I right to say that?
Or you mean, is your question related to what is panel data, or in relation to other?
It's relating to after one has imported the data, and then you have to choose cross-sectional and that other one, and then panel. And then you are saying depends on how the data has been structured. So I'm saying I see when you are displaying the panel, it's like it looks bigger and widespread.
Yes.
So does it mean the panel data is like the whole lot, everything, and these other ones are just subset of the panel, something like that? Yeah.
Oh no, I get you. So I think your question comes back to the types of data sets. So there are some aspects that you deal with in a paper before you come to the software, right? So let me maybe start to explain from there. So you would know that whether you are using any other software or not, in the main, your data mainly takes three forms. So it can either be cross-sectional, so it's about defining those different types of data sets. And again, it depends on the research problem that you are addressing. So cross-sectional data, what it is the equivalent of me as a lecturer collecting, maybe I need to determine whether class attendance affects the final, or the marks of students. Now, and then what I do is I just ask them, or even age, or where they come from, and so on. And then I just collect data maybe on a Monday. One particular point in time, I collect data on 30 students, right? Jane tells me I'm 30 years, this one says 25, so they become my data points. Now that's cross-sectional, okay? But if I want to analyze the same relationship over time, and just to say maybe I need to determine maybe the impact of inflation in GDP, I might collect data on inflation in GDP over time, maybe from 1994 to 2024, maybe. That is time series. So it's time series. It might be you're collecting it for a particular country. For South Africa, you collect that, that data set from 1990 annually up to 2024. So that's time series. Panel is a combination of both. So panel is an element of cross-sectional and time series. So by that, an example that I might give you is maybe you were dealing with time series where you wanted to look at how inflation affects GDP in South Africa, for South Africa. And your time series was starting from 1994 up to 2024. Maybe your supervisor says, no, use panel. Panel would imply maybe you say you want to, rather than focus on only South Africa, you are now including all other countries that are in SADC region, in the SADC region, or even in Africa. So in SADC, how many countries? I think around 16 countries. So what it would mean in a panel context is you are going back to 1994. In 1994, you're now collecting data on inflation, GDP, not just on South Africa now, but across all these 16 countries. 1992, 1993, 1994, 1995, you're doing the same thing. So you will see that in each year, you have a cross-sectional element of data collected across 16 countries, and then you are repeating, that observation over time from that starting year to the ending year. So ultimately, naturally, I hope you can see that if you present it in an Excel spreadsheet, it naturally means you have more observations. You have more stuff that you see on Excel because you have each country coming with how many, maybe 30, 31 observations, like from 1994 to 2024, multiplied by the number of countries. So you have a lot of observations. So that's one advantage of panel. It's a combination of time series and cross-sectional, which gives you more observations. So this is why you see that with panel, you have more observations there. So yeah, I think I answered that one. And in terms of when you use it, again, it's a question of a research problem. What exactly are you trying to address? Some research questions, some hypotheses are better dealt with using time series. Some are better dealt with using cross-sectional. Some are even better dealt with using panel data. And this is something that you will pick up as you are doing your research. But I'm more than happy to have this conversation after the workshop to say what are the benefits. But in the main, the panel has more benefits because you have more observations. And statistically, it's desirable to have more observations for additional statistical reasons, which might be beyond the introductory phase of this of the workshop. Yeah, I hope I answer that one. So in this instance, the reason why I thought of demonstrating at a basic level with 3 types is if I had only come with the cross-sectional data, I would have disadvantaged someone who wants to learn STATA, but specifically in a context of panel data at a basic level, because there are certain commands and instructions that are relevant when you are using panel compared to cross-sectional and time series. So hence I had to bring all 3 types so that once we're done with cross-sectional, we'll go to time series and you'll see some additional things that we'll do, which we would not need to worry if we are dealing with a cross-sectional. And lastly, you'll see when we are now dealing with the panel, if that's what you're working on your research, you'll see additional things that you would have to do, which someone who is dealing with time series and cross-sectional might not need to worry instead. Yeah, I hope that answers. Okay.
Yeah, thanks, Doc. It's very, very, very clear.
Okay.
The reason why panel data is like bigger data than the other 2. Yeah. Thanks.
Yes.
It's a combination of the other 2. Yeah. Thank you very much.
Thanks very much. All right. So then with the okay, so now we have captured our cross-sectional data. Now let me just touch on something that relates to the previous point I was explaining as a starting point, which is one of the most important things that you have to do with this data is to make sure that the STATA is aware of the type of data set that you are going to analyze. That's very important. If you are using time series, STATA has to know that I'm using time series. In other words, it must know that the data that I'm dealing with involves a time element. If you are using panel, it has to know that the data set I'm using, it involves both a time element and a cross-sectional element. So it's very important. Now, and you will see how we account for that aspect, how we tell the software. Now, when you're dealing with cross-sectional, you don't have to do anything about telling the software that this is cross-sectional data, and this is important. This is because by default, the program is designed to assume by default that it's dealing with cross-sectional. So it only becomes problematic if you divert from that default setting of using a type of a data set which is not a default, like time series or panel. So I thought I should just mention it now, so that when we get to time series and I start doing some things, you wonder, why did we not do it in the cross-sectional setup? So we don't have to tell the software that this is cross-sectional. Already, it assumes that it's cross-sectional. Now, maybe someone might have a question of saying, what if I don't tell the software that it's time series and I proceed the analysis? Would I proceed as normal or not? It depends on what you will do in the analysis. You might get away with it, particularly if you use expressions or operators that are not time series. Like if you want to maybe summarize, you can still summarize that, because the instruction of telling the software to summarize does not involve it understanding the time dimension of your data set. It just goes there and summarizes everything in the Excel spreadsheet. But if you now want to do something that specifically requires the software to introduce a time series operator, like something that involves a time element, like your legs, your first differences, you would know if you want to calculate, run a model in first differences, for example. There's an operator there which requires you to first tell the software that this is time series. Otherwise, if you don't do that, you see a red error, and the software will just tell you that I don't know. It will be a polite way of saying, I don't know what you are trying to do here. And you're forcing me to do something in time series when you have given me cross-sectional. So you would have to first tell it that it's time series. Okay. So given that explanation, I'm going to skip that. And what we call that part is declaration. That part is called declaring data. So you have to declare the type of your data. So I'm going to skip the declaration part because it's a default in STATA. Now, let's go to address two things more or less at the same time. But I will start with the issue of labeling, all right? Now, if you are dealing with the cross-sectional data, like the one we have at the moment, you will see that, and obviously I'm assuming that you will be familiar in terms of how we would have gotten where we are in terms of these observations. In other words, if I scroll down here, 30 means is the equivalent of someone who would have maybe distributed 30 questionnaires to 30 individuals. That's essentially what would have happened here in a cross-sectional setup. Okay. Now, in your questionnaire, you would have, in this instance, it's an assumption. I'm assuming that we have age, location, income, and education. And by assumption, location is categorical or it's dummy. And in your questionnaire, you would have clearly stated to your respondents what it means. Maybe they were just checking a box that maybe requires them to indicate if they are staying in an urban area or if they are staying in a rural area, okay? And so what you then do is when you get to your Excel and STATA, rather than writing urban in a way that will be read as you see with James, Susan, and Anna, you code numerically 101001000, right? So, and then education would be the same. Your questionnaire would involve 4 categories where Jane, for example, would have to indicate whether she has gone to school. If 1 means she is primary, you would pick 1. 4, if 4 means tertiary or PhD, it would mean that James is a PhD. So the next step really that you might want to do is to label these numbers to sort of give them meaning. so that when you are working with that data, it's sort of more convenient. It's just more advisable. Okay, so that takes us to labeling, variable labeling. And it's especially important for many of you who might want to work with cross-tabulations. If you would want maybe to cross-tabulate location and education to see maybe, for example, what is the percentage of people who have PhD and they reside in an urban area, and is there an association and so on. So it might be interesting in the sense that if you label your variables properly, your tables will be defined in a very nice way, rather than having 1, 0, 1, 0 in your table. Okay, so with labeling, then I need to indicate that you can achieve it in 2 ways. Okay, in 3 ways actually. The first way is to do the labeling here in the spreadsheet. That's the first way that you can do. The other way is, if you are now so good with the software, with the programming, you can do it in the command box. In the command box down here, you can do everything, the labeling here, and then the third one obviously will be a do file, which I haven't introduced now. But if you choose to do it this way, everything that you're doing here on this spreadsheet, it will again reflect on the history of commands here. So literally, you can then ultimately come from front to back, in the sense that you can then come after finishing your analysis and copy the commands that are relevant and simply put them in your do file. And you'll be able to do what you did manually, as we're doing here, in a split second. So let's see how that works. Okay, so to do that, you need to right click. Let's start with location. So once you right click, you see this extension here, and then this box, and then you come to data. You come to data. Then you see there will be an extension that pops up. And what you are going to do is to go to variable labels. So if you go to variable labels, you'll see another extension again. What you would like to do is to manage value labels. So the starting point is to manage value labels. So once you click it, it will show this new box here. Just in case I was too fast, I'm canceling it. So right click, data, value labels, then manage. So once you click manage, you have this box. Okay. Now, what essentially we are trying to do here with this box is, we want to first tell the software what 1 is with location, what 0 is. So you come and create your label here. So I'm canceling, I just click the create label, and then this will pop up. This pops up. Okay. So I have to write the label name here. So let me call it location. Okay. And then I have to put the values that are consistent with what I'm seeing in the spreadsheet. So 1, what is the label name? So this label name now has to be consistent with what is on your questionnaire. So if 1 meant that this person is staying in an urban area, so you might want to write urban. And then once you are done, you click add. And then the next value is what? Is 0. So you put 0. And again, so this one would be maybe on your questionnaire, it was rural. And so we now have added 1 and 0. 1 is urban, 0 is rural. If your location had 3 categories, maybe I see some studies have peri-urban. So maybe peri-urban will be captured by 2. So you will still need to add another one here. You just say 2 as a value, and then under label you write peri-urban. Okay. But in this instance, it's not necessary because our variable is only 2 categories. So once you're done, you click OK. And it will take you back to this box which you were earlier. Now, when it takes you here, you will see that you can either add a value. Let's say you forgot to add another value name, you can still do that. Or if you want to edit the label, the name, you remember we had urban and rural, you can still click this and you'll be able to edit or drop. But what we ideally need to do now is to create another one now, because we are done with location. So we're assuming that you didn't make any mistakes. So you create another one. So the other one is education. Now I'm doing for education now. So with education, I am going to assume that one means what? No schooling. Let me say no schooling. No schooling. And then after that, I add. And then two, maybe on my questionnaire is primary. Maybe three is secondary. And maybe four is what? Tertiary. Yeah. So once I'm done again, you click OK, and you see that we now have two value labeled variables, education and location. So that's a good thing. If we had another one, we don't need to do for age, we don't need to do for income, because they are not categorical variables. So it's also important for you to start with a general basic understanding of variable measurement, like an ordinal variable, a numerical variable, and so on, a nominal variable, and so on. You must know, because it's essential when you are doing your analysis. Okay. So once you're done, you can close or cancel this. And I'm just going to increase my spreadsheet. So you can then go to location and right click. We almost follow the same pattern, except that when we get to value labels, we are no longer going to manage now. So we'll go to attach. Okay, I hope everyone is okay with this. So it's data. So right click, data, value labels, this time not to manage, but you go to attach. If you want to click attach, you will see there are two labeled variables. For us in this instance, it's location, so we have to click location, and automatically you see those numbers get blue labels. Okay. Then for education, you do the same. You right click, value labels, you go to touch, and then education. Yeah. Okay, so once you are done, you can cancel or you can minimize, and you will see that in the results section, you see this information: label, define, location, label, define, blah, 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 label, values, location, label, values, location. This is the equivalence of going through the command box, and then you first type this if you are good at programming. Like if I was to do it now without having to demonstrate to someone who is new to it, I would not need to go to that, Excel, that spreadsheet. I would just come and type exactly what you're seeing here: label, define, location, one, and then you open urban, and so on and so on. And then you click enter. And then you type the next one, the third one, and the fourth one. You would have achieved the same things that we achieved here. Okay. So essentially, and you also see that you can copy them from here, or you can also copy them from here, from your command history. You can copy them from here and paste them in your do file. So now we have labeled our variables, and you can then, tabulate if you want. Let me just see if I can minimize this. Okay. So you can then tabulate. So tab is that's the shortest version of you tabulating, like you want to cross tabulate. So let me say location and education. And you will see that your tabulation appears, the output appears in the results section, but right on top here, you will see the command that you would have inputted in your command box, okay? And you can do, the general interpretation that, you have a total sample size. Yeah, the interpretation is important as well. So the total here that you see, this is essentially your total sample size. And you remember we have how many? 30 observations. In these 30 observations, we have 13 individuals who are from a rural setup. They stay in a rural setup, and then 17 of them, they come from an urban. And then out of these 17 individuals who stay in an urban, 4 of them did not go to school, 6 have primary, 3 have secondary, 4 have tertiary, and if you add all of them, you have 17 individuals with these different levels of schooling. And then in total, so the totals that you find here, the column totals, they are telling you the total number of your individuals who have no school. So it's 5 out of these 30. Those that have primary, 11. Those with secondary is 8. Tertiary is 6. So in this sample, it will be safe to say majority, they just have primary. Okay. And then, and again, the majority are from an urban setup. Okay. So this is sort of a cross tabulation you might want to compute as a starting point, but you might want to tabulate this with sort of percentages. So you might, rather than saying 4 people have no school, you might want to sort of represent that as a percentage in your study that you are doing. So to do that, you can either type again, or to save time, you can come to the history. If you remember in that presentation, we said the advantage of this section is you don't have to repeat what you might have done earlier if you want to just modify it slightly. So if you just click it here on 14 or copy and paste it here, rather than typing it, spacing it, and so on. So if you put a comma and say COL for column, and then ROW, and then you enter, you now have percentages. Okay, so you have your frequency, so you have row percentage and column percentage. Okay, so these are what you are going to see here. So this is 100%, which is the sum of this. And so this would be your sort of row totals, and you must be guided by what is here, row percentage and column percentage. And then this will be your column totals right in the bottom. So this will then allow you to, instead of saying 8 individuals, maybe say 26.67% of the individuals have this, or 36.6% of individuals have this, and so on. So, yeah. And then if you want to, sort of add a chi-square test, you can just space and write chi or chi2. And right at the bottom, it will compute a chi-square value with its corresponding probability value. Yeah, so that's about cross tabulations. Now, what I want to do now is to, if you are okay with what we have done so far, in terms of labeling it manually and so on, I would now want to introduce a do file and show you the equivalence of what we have done, or some of the things we have done. So someone asked where a do file is located or how it shows up. And for me, I think it's Control-9. So if I click Control-9, that's your do file, the one you see. I've just clicked Control and 9, and it shows this is your do file. And I'm going to cancel it and show you where else you might find it. If you just scroll here, you bump into it. It's right here, your do file. So if you click it, it will open exactly as it will show up if you control and click 9. Okay, so this is our do file. You can pretty much play around with it and place it where you are, you get where you want. You can shorten it, you can widen it. Okay, So this is where you can, let me maybe execute a simple instruction, okay, something that we have done so far, which is tabulating. So what we have done here is to simply say, remember, I can copy here and paste, or I can actually type location, education, comma, column, row, and Kaitu. Okay. So if I do this, I am similar to someone who came here and they typed that same thing that I'm typing in the script. Okay. But the only difference now is in this instance, the way I told the software to execute was to press enter. Okay. If you're working with a do file, you would have to highlight the entry that you want to be run, and then you come and execute here using this execution selection. So if I click it here, I expect to see, and you should see another table which looks exactly the same as this one. So this one must move a little bit on top to accommodate the next one, as you can see. So you get your output through a do file, which is exactly the same as one that we got when we typed in the command box. Okay. Now, as we alluded to earlier, the advantage of this is if you want to do a lot of things, you can proceed to do what you want to do, if these are relevant instructions and so on, and then ultimately you save it, file, save as, and then you save it somewhere, and you are able to come back and highlight everything, then either execute it or be specific in terms of rows that you want the software to implement. Now, if I do this, you will see that on my results section, the software ran what it could only interpret, and it was the first row which produced this cross tabulation. When it went to the second one, because I wanted it to run everything, it gave me an error. And errors are usually written in red unless you customize your software. Usually red, that's your error. And right below this red thing is a code, which if you play around your cursor, you see it allows you to click it. And if you click it, it will open something that will guide you if you don't know what you have done wrong, you see. And you are able to read that no, R119 in STATA directory means you typed an unrecognized command. So that would mean you go back to your do file. If this was a long script, you will just go to that part, and literally no one expects STATA to have a command which is HNAKSKS. Like it just got here and was like, I don't understand what you are trying me, what you are instructing me to do. That's basically the idea. So if you remember from the presentation, we said the do file allows you to track errors. Yeah, you can just track where the problem is, and if it was this, maybe you wanted to just type this, and for some strange reason, you typed that. You can come and fix it here. And if I run it this time around, it will run 1, 2, and it will stop at number 3, and you can fix it, and so on and so on. Okay, so that's basically your do file, which you can name and put it somewhere. Now, what I want to do now is to, I'm not going to set this, but I want to use our own do file, the one that you might have downloaded already, right? So if, let's say this is a data set that you downloaded from a publisher and you want to see whether you can replicate the results. So you come here and you open your do file. Okay, Dr. Sisonge, I don't know if we can just get rid of this. Yeah, thank you. So if you want to import, so you can import a do file, or you can just go to where it is and double click it, and then it will open. Okay. So we open, and then I have to, okay, go to downloads. So I named my do file, and if you remember as well, we said the extension is a do. So whenever you see .do, then it's a sign that it's a do file. So if you click open, you see that it will pop up here as your do file. Okay, right. Now, the next thing I might want to illustrate is if you are working on a do file, right? And maybe ultimately you want it to be a do file where if someone takes it and they highlight everything, they are able to replicate everything once with a click of a command, right? You just execute it, it runs everything. So to be able to do that, you must know the following thing, which is to highlight out words. So sometimes you would want someone who would use your do file to know what the next command was all about. So if it is your student, you want them to show to you that they know what that command which follows that is all about. And for you to be able to do that, you have to take it out by an asterisk. So you put a star, and once you put a star, everything after the star turns green. This is to allow the software basically to skip that part when it is running your do file. So it will skip this part and you to know that it's not a command. If you don't do it and you run everything, what you basically do is you are more likely to find this error command of saying it's an unrecognized command. But if you put a star, then it skips this part. But you might also have a scenario where you want to use 2 slashes. So if you say 2 slashes, you see after that, everything after this turns green. If you put this before this and this before that, you get different outcomes. Okay, you see what has happened here. It's in the same line. Sum is to summarize. It's a recognized command. But the software was able to get to line number 2 and summarize the data that we have, even though there is something that is in green. This is because 2 slashes allows the software to just ignore that. Otherwise, if you don't, you run into a problem. So this is also possible to do, to take out something that you don't want after an instruction. Okay. So the first one, which I put a star here, you would notice that it was literally a command that I typed in the do file to import my data. So if they were my students, I would pick correct because it's really what the instruction is about. It's about data importation. And if I actually let me do it, clear everything, so that we act like we are starting from the word go and we are utilizing our do file. So if you check here, I no longer have anything. There's nothing in the spreadsheet. There's nothing at all. So let's see if we are able to import data using this do file. And you'll notice what I'm going to do is I'm going to highlight both number 2 and number 3 and run it. What has happened? Okay. So let me correct the directorate here. Someone asked about the path. I changed the data set. That's a good thing with identifying errors with the do file. We are able to correct. This should be able to run. What is happening? Okay, right. Can I ask someone to see what the problem is? Especially in the last 4 people that asked the question, there must be someone who will be able to pick up the mistake here that we have done here. Can someone pick it up already? Especially the last person who asked. You see, it's a good thing to teach a software and bump into errors. Can someone read this mistake? The
Sorry,
error that you see here. Yes.
I think you renamed the file.
Yeah. Where exactly did we rename, if you remember?
HRSC.
Yeah, exactly. Yeah. So it would mean that I would either have to go back and rename it cross-sectional data, or if I want it to work, I think HSRC, this must work. If it doesn't, we'll go and, so this must work. Excellent. So yeah, at least we were able to encounter a problem together and you solve the problem. And this happens.
Osalu is a genius.
Yeah,
I couldn't have seen that.
Yeah, it's a good thing because you always, especially if you are working with so many data sets, sometimes you alter one small thing on your do file or in your Excel spreadsheet, and you forget that you wanted to illustrate something, and you still think that your do file is perfect. Yeah, so this was an excellent way of learning. Okay.
Doc,
So
while
this is,
you are here, before you move
yes.
on, Tolulope asked a question regarding how can someone copy a working directory path into a do file?
Yeah. Was it that question which had to do with the directory?
So she's asking about the directory path and copying that onto the do file.
Yes, actually, it's the equivalent of you copying it from here, right? And then just pasting it here. So this is the path here. So this is my computer. Okay. I think I understand what. Okay, so if it is not working on your part, actually, if you use it the way it is, it won't work because it's following my direction, my own path. So the easiest thing for you to do, I want you to do this for me. Import it, in case you don't know, like the directory, your own directory. Just go and import it using this route we did, and it is going to import your data, but it will clearly show you. You'll be able to see going forward your path here. So you can just copy this path to be more accurate, and then you paste it here. That will be the only thing you would need to change in your case. So you come and paste it here. The alternative is to, if you know, you can just edit from here because this is following mine. It's in users, it's in C, users, admin, downloads. It doesn't have to be all these three compartments. If it is just in admin, then you might not need this, for example. Yeah, so just make sure. And this is the reason, by the way, why I started with this easier one of file import, because it will clearly tell you going forward what your path looks like, and you can just type it in. Okay. Is there any other question?
Yes, there are other questions, but I suggest we save them for the end because
yeah, we might not finish. Yeah, all right. So if I go back, colleagues, to this data set, you will clearly see that because we cleared everything and we started afresh using a do file, we almost have to start again in terms of labeling. But thank God, with a do file, we won't take much time. Where is it? I hope I did. Did I label? Yes, I think I did here. So if you, and someone asked whether you can run everything or you can run selectively. Yeah, you can run everything or selectively. So if I highlighted everything like this and run it, it will run. But I'm not going to do it because I want to go stage by stage. But in this instance, I want something specific. And it has to do with labeling, the labeling that we did. So the part of labeling is here. So I'll just highlight this section. And if I run it here, you will see back here, you almost have the same labels that we had in the previous illustration. And if I click on the data editor, you see my variables would have been labeled. Okay. Now, if you want to do like basic manipulation, like your summary statistics and so on, the command for that is summarize. Okay, summarize. So summarize tells STATA to compute a summary statistics table where you have your mean, your maximum, and so on. Now, in this do file, you will see that I have some and then some with something that is different on the right side of some. And I'll illustrate why I did so. I did it deliberately. So if I just run the sum, you see what the software would have done. It will summarize everything that is under variables here in this table. It will summarize everything. But then it might not be appropriate in situations where it might not be necessary to summarize everything. In cases where, think of a scenario where you're dealing with maybe 26 observations, 26 variables. So you'd have 1, 2, 3, 4, 5, 6, up to 26. So if you type sum, it will summarize, oh, this table would be ridiculously long here. So there might be, the point then becomes, there might be cases where you only need to summarize some or a few variables. So to do that, you have to specify the variables specifically that you want to summarize. So number 8 is different from number 7 in the sense, number 7 is different from number 6 in the sense that it's telling the software specifically which variables to summarize. So if I run number 7, that individuals does not appear here because I didn't list it here. Now you can then come here and interpret your summary statistics, and you would know how age is measured, how location is measured. We know income, education. Now summary statistics is important. It's also another way of diagnosing a data issue that you might have missed during cleaning. For example, if location, you know that it's a categorical, it's a dummy variable with 2 categories. If you look at the minimum and the maximum and you have the maximum of 3, clearly that will tell you that there's a problem in coding. So the person who coded data from your questionnaires into your Excel before you imported might have made a mistake. So you are able to pick it up from here as well by looking at the maximum of your variable. Similarly with education, if you know it has 4 categories and 4 is the maximum, so 4 must be there. Maximum number, assuming that your numbering is ascending order 1, 2, 3, 4. So this is a good sign in terms of our categorical variables because it's 4 categories and the other one is 2 categories. So it's a good sign. It will also be problematic if you found something maybe with -2 and so on. It might indicate that someone captured it incorrectly. Then this will be the average age, the standard deviation, the minimum value and the maximum value. Then when it comes to one other thing that I wanted to indicate is you must know that when you are summarizing, there's always a question of saying, does a mean value of a dummy variable make sense? Is it reasonable statistically to interpret it? And most researchers actually say, no, you don't have to interpret a mean, but you actually can. It actually says something because if you look at 0.56, right? I want you to see something. I'm not going to the do file. I'm just going to tabulate location there. And you see something here. If you tabulate it this way, you will see that the mean value of a dummy variable, which has 2 values, 0 and 1, is essentially the proportion of the group that is taking the value 1 in your data set. So you look at this number, mean here, it's exactly the frequency here. It's the same number. It has been rounded off to 2. Okay. So the point I'm trying to make is if your categorical variable is only 2 categories, 0 and 1, the mean value can tell you the proportion of the group that you assigned the value 1. So in this instance, 56.7% of the population, I mean, in this sample, they reside in rural areas. Okay. And then income, you'll interpret it knowing the measurement. If it is in million rands, that's the average, the income of a typical individual in your sample. Okay, I'm just trying to be a little bit fast. And then if we go back to our do file, what else can we want to do? You might want to do so everything. You can run this, and you'll be able. This will be okay. Before I go there, now number 8 in comparison to number 7. While it summarizes age, location, and income, but it adds something that STATA can do, and that is to use the if qualifier. The if qualifier. So if qualifier is you telling the software a condition, a particular condition. Okay, so you want it to do something conditioned on. It's like for those of you that have done conditional probabilities, you are conditioning something. So that condition really depends on what you're doing in your analysis. It might be that you want the software to give you summary statistics, but only for people who have at least secondary school education. That means from secondary school upwards. You don't want your summary statistics to include people with primary or no education. That might be a condition, or the condition might be you want only summary statistics for people with tertiary education. So to achieve those types of conditions, which by the way, if you then move into different data sets like your time series, a condition might be you want a line graph, but that only starts from 2010 going forward. It could be a condition, and you can do that. So in this instance, what this means is after if, so you see if it's in blue, is to tell the condition to STATA. So with this, because I know that 2 is what? I think 2 is secondary. So this means I am computing summary statistics for only individuals with undergraduate and postgraduate degrees. In this instance, I hope you understand that. And then this one is telling STATA that only summarize statistics for, summarize your statistics for individuals with what is 1, with no schooling. So if you run number 9, you'll be able to see that you get another summary statistics for the same variables, age, location, and income, but what will have changed is the number of observations. So the sample size changes because of the condition you gave. If I run the top one, number 8, you will see the sample size is also changes. That is because this is now the sample size of comprising individuals that are meeting the condition that we instructed the program. Okay. And it might be important in papers where reviewers might require you to maybe plot different time plots for different decades, for different periods, or for different individuals and so on. It might be of interest. And of course, you can do all different things. You can plot a pie chart. I'm just running graph, pie, and then over education, you can have it. If you want percentages, you have P label underscore O percent, and if you run that, you have a pie chart that has percentages, and then this would be for location. Obviously, I think this we have done just this on this one. So now let's move from basic. Now I'll come back to a do file. The alternative is obviously to come to graph. Like if you want to remember this, you can come to graph here. You see, once you click graph here, you see pie chart, bar chart, histogram, box plot, scatter distribution graphs. So it will depend on exactly what you want to do. And you also see that there are some graphs that are only relevant for time series and panel data only. This is where that point which I emphasized earlier to say you might need to declare so that the software does things knowing it's panel or it's time series and so on. Because if you then come here and you did not tell the software that it's time series and you try to plot it, you'll get an error message to say, it's unrecognized. It won't unless you declare and you tell the software what is the time variable. So that's really important. And the same applies with the statistics. You can come via here, you can frequency tables that we have just done, you can actually do them by coming here. And if it is a one-way or two-way table, you see it will allow you to, determine which one is your row, which one is your column variable, education, and you can pretty much play around with additional statistics that you want to appear after, just below the table. If you want a chi-square, and then after that, you submit, you see that the table appears here. And I hope you can see that it's almost the same command that we had to type either in the do file or in the command box. So this is, I would advise that you use this route if you are still learning, because it's easier. You don't have to memorize the command. You just need to know that what I want to do is to tabulate. So I'll go to statistics and I'll look for tables, and then I will determine what exactly am I trying to do in my study. If it is a contingency table, then I'll come here two-way, and what is my supervisor needing? Is he requiring a likelihood chi-square? Is he requiring Kramer's? What else do I need? Blah, blah, blah. Do I need to show percentages and so on? So you can pretty much play around with what is here, depending on what you want to do in your study. It's not a matter of, I see students sometimes, they just take anything here. It can do this, let me do. It has to be context specific in terms of what you're doing in your study. You don't have to take everything that you find in STATA, okay? And then if you go next to, besides this box, you will see this box is written by and if. So this if here is exactly this expression, which is equivalent to the if condition that you would write in a do file. So that is to tell you that STATA has so many ways of doing exactly the same thing. So you can create your if here, and your if might be you might want to restrict your number of observations, maybe 1 to 20 and so on, depending on what really you are doing. Okay. Let's see next what is on our do file. Next, in terms of graphs, if you want a histogram, it's just a list. Okay, you can write a histogram or just a list. So because it's here, I hope you will see that in the do file, I only added an instruction of plotting a histogram only after transforming my income into logarithms. Okay, so to do that, I would have to first generate a new variable. If you remember, you have to generate a new variable, which is the log of income. I hope this explains this part. But if you want to have maybe scatter plot before you transform your variables, it's simply scatter, then you put your variables. Okay, so if you highlight this and you enter, you see a scatter plot popping up very soon. So this will be your scatter plot. Okay, you get the same thing as typing here, scatter age income, and you enter, you get your graphs. I don't know if I had indicated that graphs, they pop up somewhere in STATA. They don't appear on this box. They will pop up somewhere. So you almost have to look for them after executing a command. Okay. Now there's one thing that I want to stick to your heads now, that this is an unconditional scatter plot. You're not conditioning anything here. And it's a standard scatter plot. I'll come back to this point later. Now, so we now know how to compute a scatter. And by the way, I hope you can see that all the experiments we are doing, they are being listed here in the review command. So you can literally see the red elements would be cases where we encountered some problems. Okay. All right. Now we know how to plot a scatter, and a histogram, it will simply be hist. If I wanted to plot a histogram for income before transforming it, I would just type hist space income. And it will use the defaults of your bin size, 5, these are defaults, okay, and it will appear here. Now, let me introduce you now to the next concept, which is to generate new variables. So in this instance, the new variable that I generated was basically income that has been transformed into logarithms. Now, to do that, you can either type here in this command box or in that do file. I'm not typing in the do file because I already typed it in the do file. Yeah, so if I had not done that in the do file, I would type this gen. Now, I want you to listen very carefully. So gen is a shortcut for generate. You use it if you're generating a new variable. Now, after gen, you put space. The first variable name that you put there is the name of the new variable that you are generating. If you want the new variable that you are going to generate to be called a car, you write a car here and then you space, right? So then after putting an equal sign, you then put the expression. If you remember from our PowerPoint presentations, you put the expression that tells the software sort of the data generating procedure for that particular variable. Like what exactly would the software have to do to generate that car variable? In this instance, we want to log it. So if you want to log it, you just type log and then you open. And then after that, you type income. You either type it, or if you don't want to type, you can come to where variables are, and you will see right next to it, there's this arrow pointing downwards. Once you click it, it will bring it down here in the command box. And you can then close, you put the close bracket. The reason why I encourage you to use this one, clicking it from here. Why? Because I've encountered with my own students that they encounter mistakes of typing very often. Like, even if they are looking at income, like it's capital letter I-N-C-O-M-E, for some reason, they might put an I there, they might put a dot, and that might be problematic because what will be in this bracket is something that is already in STATA. If you put something that is not in the software, it will just tell you that that variable is not found, like it doesn't exist in the current data set. Now, the reason why I put car here is if I run it, can you see that right here under variables, there's an additional variable called the car. So there's a new variable called the car. This is because I deliberately chose to call that new variable car. I can call it what I want, elephant, horse, or so. But because it's just unusual in research, you want to write something that is very close to what you have done, right? So the point then becomes, I would achieve the same thing if I said log gen log income, and then equals to log income. You will see that I now have log income just below car. Ladies and gentlemen, this is essentially the same variable. I have similar values, just the naming here. If you want to see that, you can summarize these two variables in a table to see if exactly is exactly as I'm indicating. You will see that with the summary statistics, everything is the same. The mean is the same, standard deviations are the same. It's just that I preferred to call the first one car. But statistically, it just makes sense for the natural log of, income to be log income. I think that's important because if you know that, you will know that essentially when you are generating a new variable, you can call it, you can play around with this side. This side, the left-hand side of the equal sign. You can play around, what you cannot play around is what is in this bracket. It has to be something that is available here. That's the point. Okay, so let's generate log age equals to log age, and you click enter. So what I've done here in the command box is equivalent to someone who did this in the do file here. Number 26 and number 27. Right. Okay. Now, just on this aspect, I might want also to indicate that Remember, I indicated that one of the good things with the do file is it allows you to run everything if you want and you be able to see results. But you must also be careful in cases like these where you have already saved your data sets and there are some transformations that you did. Specifically here, you've generated new variables. If you were to rerun this again, it will get to number 26. It won't be able to do this because this log income already exists. It will tell you that log income already exists. So if you find that error when you are dealing with your data, just know it's because you are running a command that generated a new variable before, so you might need to find a new name if you still want to do that transformation. Okay. So we can compute a histogram. So this is the histogram of log income. And you can achieve this by typing this histogram log income. You achieve the same thing. You can also achieve the same thing by, for those that are still new, come to graphics. Where is histogram? Here it is, histogram. And what is it that we want? So you come to variable and you come to log income and you submit. You get the same thing. So I don't agree. That's why I don't agree with anyone who says it's complicated. It just depends on which way are you analyzing your data. And it's actually easier if you come this way because you have a whole lot of things next to you that you can do to play around. You can adjust the number of beans, the size, the width, and so on. And you can choose to change whether your y-axis is in density, fraction, or frequency. Or for some of you who might want to add like a density plot in addition to that histogram, you can come to density plot and whether you can pick if you want a normal density plot or a kernel which is non-parametric. And if you do this, you click submit, you see in addition to that, you know, those distribution plots appear. One which is a normal distribution, the other one which is a kernel density. So it depends on what you are doing in your analysis. Some empirical papers require you to also plot a kernel distribution. You might want to do that because it might have some statistical advantages, which you might not have to. And again, if you want to rename your graph, you can do that here. Y-axis, you can change your x-axis, your titles, and so on. So you can customize your graph here. Okay. Now let's see what else before we move. You can compute a correlation matrix. This is the command for a correlation matrix if you want. So if I highlight this and I run it, so this will be the correlation matrix. And again, I would achieve it if I had to type, although it comes with the risk of typing something incorrectly and you get an error. Yeah, so you get the same thing. Okay. Then what else might you want to do? Okay, so then there's something that I want to tell you, linking to what someone said about adding add-ins. Now, this STATA is an additional support feature of sort of accommodating those scenarios where someone just realizes that, you know what, why can't I come up with a command that exports everything or anything that you want from the software to a Word document? Because maybe you're working on your research and sometimes it might be tedious for you to go there and in Word document, create a table, and then you start to put these values minus 0.5, minus what, and this applies with regression as well. With this data, you can install something called ASDoc. This is an extension which is not something that was in STATA when it was originally designed, but it's an example of what someone asked you to say, can you come up with your own code? ASDoc is something that was designed by someone who probably doesn't work at STATA, but he or she just realized that if I have a command that allows a researcher to export everything that they are doing, it will save them so much time. Okay, so let's do things here. AS doc, then log income, log age. Okay. AS doc, log income. A red line always shows you that you have made a mistake. So if you see me quickly redo it again, then I would have just seen this red line, and I'm not going to click this because I know what the error is that I had done. So in a way, it's a good thing. So you will see that after typing sum, I'm summarizing, but before summarizing these variables, you must tell it to export it to a document format. And so it will do this, summarize log income and log age, but just below this, there is a file, a document, which if you click it, it will open exactly your, what you call it, your exported table. So you see here, there are two tables, such tables, because I did not create a new document. I had done it before. Or literally, you can then copy the one that you want and paste it in your research. It's much easier to then go to your study and just expand your correlation matrix table or your summary statistics from a Word document rather than starting from the Word Go. Okay, so there are so many other extensions that you can do depending on what you want to do. Right, let me, and then if you have STATA and you don't have it, you might need to install it depending on where it is found. So usually, if you want to install something, you type SSC space install, and then you put that command. And if you enter, you have to be connected on internet, by the way. So the first thing that it will do is it will check whether you don't have it installed already. So in this instance, it just says it's up to date because I already installed it anyway. So this part, I think it's important to emphasize as well that if there is something that you found which you want to do, like for example, someone spoke about meta-analysis. So the only thing that you need to do is to find the code of doing a meta-analysis in STATA. And then you check whether your edition can handle it. If it doesn't, you check to see if you can install it if it is found in the STATA repository. And once it is installed, you don't know how to use it, you don't necessarily have to contact me, you don't have to contact anyone. STATA is a help file. So you can either come to the help file and look for that command. Help file is everything that you can ask how a particular command works. In this instance, let me just experiment by typing help AS doc. Once you enter, you see this help box. So you're never lonely with STATA. So here, if you don't know how it works, it will explain exactly what you do. And some commands, if you scroll downwards, they actually have examples. You see examples, like in this instance. You can see that if you didn't know, you can actually just copy this and paste it in your command box or a do file, and make sure you customize by putting the variables that you want to be summarized. So you will see that there will be examples that are available in STATA, and also what you only need to do is copy one example, then come here, paste it, and maybe just customize it by adding the variables that you are dealing with. So you are never lonely, but you need to be connected to the internet for you to be able to install anything. Okay, so quickly, because we are running out of time, let's move on to
Dr. Brian, we have 19
Yes.
minutes left.
Yes, yeah. Let me quickly move to regression analysis. So regression analysis is REG, and I'm going to assume that the regression that I want to estimate, maybe my dependent variable is income, log income. With this data, you type REG space, the first variable that comes should be your dependent variable. So you click it, and then everything after that becomes your independent variable. So if I just run this by enter, this would be my regression results. Now, interpretation will be as it is in any other software. So this would be your slope. So this will be its standard error, this will be its t-value, this will be its probability value, this would be your lower limit of your 95% confidence interval, this is your upper limit, and this is your constant term or your intercept. So these are your regression results. Right on top here, you sort of have your ANOVA, analysis of variance, which is not really particularly useful in some applications. What is more important is this part and this part. So this part, you have your number of observations and your F statistic for those of you who are familiar with this. So this sort of tests the overall significance of the whole model. And then this is its corresponding probability value, which you typically want it to be below 0.05. In this particular instance, it tells us that this is a bad model in that the model is jointly insignificant if we had more than one independent variable. Then this is your R-squared, which sort of tells you how good your model is in terms of fitting the data. So 0.65, if you multiply by 100, so it means your model explains only 6.5% variation in log income, and the remaining, I don't know how many, 90 something, 93 point something is explained by the residual. So this is a poor model in terms of explaining variation in log income. You typically, the closer it is to 1, the better the model. And this is your adjusted R-squared, which you would typically prefer to interpret if you are dealing with more than one. In other words, if you're dealing with a multiple regression with more than one independent variable. There are reasons why this is preferable statistically. Then this is your root mean square error criterion for precision of your overall model. So that's about it. Then in terms of your interpretation, now because this is a double log model, it's a log-log model. So your interpretation of this one is an elasticity, as many of you might know. So this would imply that, for example, a 1% increase in age is associated with a 0.50% decrease in income. And then in terms of statistical significance, you see that this is above the maximum 10% level. So you basically fail to reject the null hypothesis that says this coefficient is 0. So, and we will naturally conclude that, 8 to 10% level, log age is an insignificant association with income. The intercept, we don't typically interpret it for several other reasons beyond this scope. Now, let me then proceed to something that I think I should illustrate, and which is that when you are doing your analysis, you might want to have a table, or you see how it looks. You might want a table that has different regression variants. You might have seen this in different journal articles where one table has different variants. Now, one way of doing that is to run several regressions, changing something here. Might come here and the editor maybe said, estimate another regression, but where you add a location and add another regression where you add your level of education and so on and so on, and then put them in one table and then compare, see how those results differ. Now, one way is the tedious way is to have these tables, print them out, and then you start to type in a Word document elsewhere. You don't have to do that with STATA. There is an extension which, similar to ASDoc, you need to install this command called outreg2. Okay. So with this one, what you basically do, and by the way, everything that I'm typing here is in the do file, so you are able to replicate this even after the workshop. So what you will do is you regress your first model, which is your parsimonial specification, which only includes one independent variable, for example. And then you come to this section, if I am to link it so that you won't get confused when you're looking at the do file. I illustrated it here. Here, you'll find it here, where there's outreg2 and blah, blah, blah. So you say outreg2 so after this, you typically have to write something, the name of the document that you ultimately want to show up. So let me say what is I not written before, my SPU, my HSRC, and then doc, and then you put a comma, append, C title, then maybe you call it module 1 and you close, okay? So don't worry if it appears so long. It's just a command that you copy and paste and you customize it. Now, if this is your first model, so you run the second one, which maybe the editor said you must do, maybe they said you must add location. And so what you need to do is to copy that outreg command. And the only thing you are now changing is to say this is now the second variant or the second model you enter. Then you run the third regression. I'm just copying because of time and I'm pasting here. Maybe you add education. So you might want to call this module 3. Okay. Once you are done, you can click this document and you see it will export a good document with your regression results. So it's much easier because it has already put your coefficients, your standard errors below, which is a typical way of representing your regression results in a journal article or in a thesis. And it already has your parentheses, your standard errors that it indicates significance. And clearly, because you don't see any asterisk next to this, you see that none of the variables are statistically significant, but it's very convenient when you're doing very large tables. Okay, let me just see in 2 or 3 minutes. Okay, so I'm going to clear. I don't have anything now. So what I'm going to do is to import again, but this time around, I am going to use okay, let me do this. I'm going to illustrate using, okay, clear. This is a time series spreadsheet, Excel. Dr. Naidu, you can stop me at 12, maybe 53. I hope I'll be very fast to cover this.
Okay,
yeah, 53. So, okay, demonstrate, first row, this, then, okay. Now, this is now the time series, is it? Or did I do that? No, I didn't. I want the time series 1. I just want to illustrate one aspect with the time series. Yeah, this one. Okay, so this is, you see, I now have a new set of variables, trade and GDP. And if I come here, I'm able to see my variables. Now, this is time series. Now, I want you to see something. If I say REG, like I want to regress, maybe GDP depends on trade. You see, I get results. Okay, but this is time series. It starts from 1960. It's not cross-sectional. These are years. So the reason why STATA was able to run this is regress doesn't really take into account the time nature of the data set. But if I want to then introduce maybe something, I hope I haven't declared it before. If I want to introduce something that uses a time element like a lag, okay, or changes, and a change, you put a D and a full stop. You will see that you get an error that says time series variable not set. D is a way of you introducing a first difference operator, like expressing trade in terms of changes. So this is the reason why it's important to declare. So for you to declare that it's time series, you just need to say T set, and then you type the name of the year variable, the year indicator. So if I do this and rerun this, I must get results where trade is difference because it now takes into account that it's a time series data set. I can also plot a time series line if you want a time series line. Sometimes time series plots are very important in time series data. You can actually do that by TS line. You put GDP and you would have your graph pop up. If you want to put them on the same graph, you can do that, although it might be messy because the values are so far apart. Yeah, it might not make sense because your trade values are so small compared to GDP. Yeah, so that's essentially the idea. And you see here that the coefficients are either too big and that has to do with measurement issues and so on. And after this, if you want to do your post-estimation diagnostic test, maybe testing for heteroscedasticity, it's just a test. And your now hypothesis says that there's no heteroscedasticity, so this is a good thing because the p-value is above 10%. And if you want to test for model specification, for those of you who do regression analysis, it's just OV test. You enter, you get your diagnostic text. This p-value must be above 0.1. Yeah, so it's still correlation, residuals, and so on. You can do that. Now, if you want to generate or predict, create your residuals, you type predict recede, you see right here, you have your residuals. You would be familiar with the residuals, and you can plot them on a histogram by typing hist, recede, and you can sort of see the plot of your residual. Now, if you remember, there's a graph that the scatter plot earlier on. If maybe I just initially had a scatter plot of GDP and trade, I would get something like this, right? This is an unconditional scatter plot. But if I do this scatter GDP trade, trade, and then use this command AV plot trade, I will get a new plot which is a conditional one. So this works well if you have more than one independent variables and you want to sort of look at the association when you are holding constant other independent variables in your model. Okay. I think I can stop here because I don't think we have enough time to go through panel data. But if there's any question, I think this is the right time to pause it so that I can explain any aspect you might have been waiting for, but we couldn't cover due to time.
Yeah.
Okay. Yeah.
We've got about 6 minutes, and there are questions in the chat that we did not cover. So I'm going to ask colleagues on the call to raise their hand.
Yes.
So that they have an opportunity to ask their question directly to you. Thanks.
Yeah. Okay, I cannot see hands, so I'll be just waiting for your voice to show up.
Colleagues, please unmute. I'm looking at the chat in the meantime.
Okay, no problem.
Okay, let me then proceed. So James has been asking about, for example, the variable education.
Yes.
Here there's an option for including other specify. So he would like to know how to code such a variable.
Okay, but you come again, how to do what with education?
So the education variable is a categorical variable.
Yeah, and it has more than 2 categories, né?
Yes, so he's asking though, if there's, say a 5th option within that category for other specify. So it would be
Yeah, I'm not sure I understood the question. I mean, is it saying that if the education category, for example, is a 5th option of other, is it?
Other, and it would be specify. So for example, if you've said
okay. No, I think I know. I think I get the question. Or to say, if your questionnaire maybe lists some common categories, and then I mean, the last option says others, and then the responder has to specify what that other is, whether it's a certificate or something, right? And they have to write it what it is, right?
Correct.
Yeah. So on that one, you see, it comes back to what you want to do, because there's something that I would have done if we had time. Or if you look at the aspect which I could not do because of time, you will see that on number 44, you see that on education it is 1, 2, 3 categories, right? And you also see that on number 36, education is an I.education. right? Now, what I would have explained here if I had time here was to say, depending on what you want to do, and I hope this will answer exactly what you asked. What I would have said is, you must notice that education is more than 2. It's unlike location. Location is easy because it's 0 and 1. But for a variable that is education, which is more than 2, you must then come back to your research study and understand what you want to do and how you specified your model, right? Now, I'm going to give you different scenarios. The first one is to know how you would interpret the coefficient that is associated with education, regardless of what you have done in terms of categorization. So if I had, let me do it practically. If I had, where is it? Okay, let me just quickly do that. If I had run it without categorizing, what would have happened was I was going to see only one coefficient, which ignores the fact that, okay, yeah. So if I was to do this, income is my dependent variable, then age, then education. If I was to run this, you see that you only have one coefficient. But then the way you measured it in your questionnaire makes it less, I mean, it won't be reasonable to interpret this coefficient anyway. For it to make sense, what you would have to do is to do this. And you see this will answer you directly. So if you put your I dot and you put education next to it, rather than having one coefficient as you saw here, you now have 1, 2, 3. So I'm not sure how far you are in terms of statistical analysis, but if you have done it to sort of to an intermediate level, you would know that concept in statistics, which says if you have a categorical variable that is m number of categories, in other words, that is 5 in this instance, or 4 in this instance, you can only include in that model m minus 1. So one of those categories will be dropped. Now that depends on what you are doing in your study. If that other category is something that is of importance to you, like you really need to understand something about it, then you have to decide to say, am I going to say I'm comparing each and every group that has been included in the analysis with everyone else who studied everything else that is not these 3 categories that are appearing here? In other words, let's say your other categories, you're finding people who are saying certificates, people who are saying self-study, people who are saying vocational training, for example. They are specifying different variable, I mean, different, sorts of types of learning. It's all about interpretation. Now, if you assume that all those other names are captured by the dropped category as a single category which has been dropped, then your interpretation of these coefficients would be, for example, income of people who are, number 2 was what? Secondary. So on average, the average income of people who have secondary education is lower by 5,741.59 rands compared to the other category. So you would have to know as a researcher that other means this is a person who has anything else that is not secondary education. And your interpretation again goes to the third one, which is tertiary. So your coefficients would be your dummy intercepts. So you are comparing the average incomes between someone who was very specific that I have tertiary compared to someone who has other types of learning that they would have specified. Yeah, so that's what I would say on that aspect.
Doc, so we're sitting at 1 minute after 1,
Yeah.
and
Yeah.
I wanted to ask you if you would like to very briefly speak about the use of AI and perhaps provide.
Oh, excellent. Imagine I had, right. So STATA you shouldn't be lonely. Like the good thing is with AI, ChatGPT to be specific, it allows you can even ask it any command, like you can tell it literally anything. So I have an example here. let me see if I can. Why is this tab right at the bottom here? Is this on my side or is on that side? This tab here. I just wanted to show you. Okay, yeah. Okay, so yeah, I have an example here. There are so many things that AI can do, ChatGPT can do to really help you navigate this data. You can ask it a command if you have forgotten it. You can ask it how to deal with a particular bug. You can paste your command, it can correct for you. You just write here, what is wrong with my command? STATA is saying this. And then it will really give you a cleaned version of a command, which if you go and paste there, it will work perfectly. If it doesn't work perfectly, it's so nice that you can take it back and say, I tried what you said, but this is an error that I'm getting. It will correct again and say, oh, it is because of this. Now paste this one. So you're able to copy. Now, what I've done here is to just give you one example. You might have a scenario where I don't know if majority of you are familiar. There are papers, particularly by the International Monetary Fund, where they might want to plot what is it? They might want to plot a distribution of a variable, maybe in 2 different time periods. And then they will plot that histogram on the same graph. It's something that you might on your own struggle to do. But look at what I have done here. I went to ChatGPT, for example, and then I say, how do I plot 2 histograms with different colors on the same graph in STATA? And then it will give you the syntax. It might explain if you want it to explain and you are very new to STATA. But if you're someone who already knows and you just want something very quick, you just copy this. You see, it's actually output from ChatGPT, which is a command of what you want to do. Then what you will do, but what it does is it gives you a generic answer unless you were specific to say these are the 2 variables that I want. So if this is the data set that you have, all you need to do is to go to your do file and then you paste that command which GPT gave you. Now, the only thing you need to do is to know which 2 variables. Remember, I said I need 2 variables to be plotted on the same graph with different colors. So I will replace variable 1 with the variable that I want. But really what I want to do here is to plot employment maybe after 2010. So I would say after 2010, and the next variable is still employment, but these are 2 distributions for 2 different sampling periods. So this would be 20, so after and before. And the variable names would be either after 2010 or before 2010. Before 2010. And if you run this, you see how easy it is. It's very difficult for you to really remember such a long code, but just telling, ChatGPT, look at how nice it is. It will just show you the distributions. It's the same variable, but the distributions are capturing before 2010 and after 2010. You can pretty much ask anything in ChatGPT. If we had time, I was going to show you different examples of how you can navigate, use AI to really aid your analysis. You can ask, how do I install a new command in STATA? And it will tell you something. As you can see, SSC install, you will remember that when we installed ASDoc, we had SSC install space and you had to type. So literally, there is no reason for anyone to say I'm struggling with this data because AI is there to give you that guidance. Like you can literally do anything, even a problem that you encounter when you're doing your analysis, even though STATA is its own way of resolving issues, you can take advantage of that. So you can copy this mistake that you might have, and you can literally get good guidance. Like I encountered this error in STATA, how do I rectify it, and then you paste it here. It will literally tell you why it means the STATA cannot find that variable, and literally you can go there and put the variable the way it is appearing. So it's
Thank
very sad
you.
that we are out of time, but I hope it's a conversation we can have afterwards through email on what are the things that you can do with AI using STATA.
Thank you so much, Dr. Brian. I think with that, we would really like to thank you for your presentation and also to thank colleagues on the call. Thank you for staying with us and for your interaction with Dr. Brian. And please remember that the presentations are available on the link that Sisonke has posted. As Dr. Brian has said, he's not leaving you alone. He's given you tools to be able to start STATA if you haven't, and then continue if you actually have learned the basics and want to proceed further with using STATA for your analysis. And lastly, I would like to please remind you to complete the evaluation form, which Sisonke has posted. And Dr. Brian, do you want to say goodbye to colleagues before we leave the meeting?
Yeah, thank you very much, Dr. Naidu, for facilitating the session, and Dr. Sisonke for doing the technical analysis in the background. And most importantly, the participants, thank you very much for the interaction. It was quite fruitful. I hope that I managed to at least give you the basics. It's just unfortunate that we didn't cover all that I thought we could, but I mean, learning a software is a process, it's not an event. So I just like you to, I just want to thank you for your patience, staying along. It's not easy to listen for about 3 hours. So thank you very much for your patience. And I also want to indicate that learning a software is a process. I'm a very open person. I'm reachable. I think my email address is available, I think on the website. I think I supplied it. If you find something that is really bothering you, an error, and you don't know how to get over it, feel free to reach out. I can give you the guidance. That's what research is all about. So thank you very much, everyone. Back to you, Chair.
Thank you so much, colleagues. Have a lovely afternoon further, and please do remember to join the Academy later on and tomorrow as well for other sessions. Thank you so much. Goodbye.
Bye-bye.
Thank you. Bye, everyone.
Thank you. Thank you, colleagues. Bye-bye.
Thank you so much.
Bye-bye.
Bye. Good afternoon, Ingida Esaias Dube. How are you?
We are good, thanks. And how are you?
Fine, thank you. I see you trying to access all the links. Which one are you looking for?
The readings.
Mm. So are you trying your luck all those tracks?
I'm not sure if I'm the right person. I thought you were greeting.
Yes, I was greeting. Actually, I'm looking for Ingida
Oh,
Esaias Dube.
Ingida. Oh, okay. No, it's not me.
Yeah, Ingida, can you please unmute? Or maybe you're not Ingida, you're calling yourself with a different name, I'm not sure. You might have shared the link. Ingida. Ingida, you're not responding. I'm going to give you 5 minutes. Thereafter, I'll remove you because I see you occupying all the links, all the tracks. So I'm not sure why are you doing that.
Hi, good afternoon. Just want to check if our chair is here.
Good afternoon, Mary. Hi, I'm here.
Okay. Okay, just wanted to, do you want me to share already the slides, or you want to finish the welcoming before we share the
Yeah.
slides?
You can keep your slides up.
To know where they're joining or what they are connecting to.
Sure, you can keep your slides up and then I'll do the welcome. I think we'll give people another 4 or 5 minutes to join.
Okay.
Okay.
All right, thanks. Can I also check if Dr. Mbuzibeni is here?
Good day. Yes, I am here.
All right.
Can you hear me?
Yeah, I can hear you. Thanks.
Okay, perfect.
Yeah.
We have more people coming in. According to my watch, we've still got about 2 minutes. I don't want anyone to miss out the beginning. Let's just give them 2 minutes. Okay. Good afternoon, everyone. I think we can begin. And as people join, they can catch up. I'd like to welcome you to this session this afternoon. The session is on conducting systematic and evidence reviews. I will be the chair of the session. My name is Sarah Naika. I am a senior research specialist with the Research Development, Science and Innovation Unit at the HSRC. With us today is our technical facilitator, Mr. Kefius Baloy. He'll be here for all of our technical support, to kind of the backbone of the session to help us get through it all. I'd like to welcome our presenters of the session. This will be a very interesting and intensive session. We have Dr. Mary Mangai, who is a senior lecturer and faculty research representative at the School of Public Management and Administration from the University of Pretoria. Mary obtained her master's in economic development and policy analysis at University of Nottingham in the UK, and her PhD in public administration in the Netherlands. She has vast experience in research, training, teaching, supervision, publishing, and consultancy in public policy and management, collaborative governance, crime prevention, citizen participation, co-production and co-creation of service delivery, and developing countries. We also have Dr. Mbuzaleni Hlongwa, who is a senior research specialist in the Public Health, Societies and Belonging Division of the Human Sciences Research Council, also an honorary lecturer in the School of Nursing and Public Health at UKZN. He holds a PhD in public health from UKZN, and his research focuses on HIV prevention and care, particularly among men, alongside health systems, service delivery, and social determinants of health in resource-limited settings. With us also is Dr. Austin Ayodele, who's a postdoctoral fellow at the School of Public Management and Administration at University of Pretoria. He holds a doctorate in criminology and penology from the University of Ibadan in Nigeria. His research expertise and publications cover violent and gang-related crime, victimology, human security threats, and policing. He's currently a researcher at UP in South Africa, where he collaborates on a number of co-production initiatives. So we've definitely got the expertise and the breadth of experience to help us through this session today. I think we can begin with, maybe I'll give you a short just outline of how we will kind of flow through the session. We'll start off with some of the objectives, the overview of review types, planning of systematic reviews or evidence reviews, and then we'll get into some hands-on searching and screening, and then synthesizing and reporting. We will have time for questions, Q&A, feedback, a little bit of discussion towards the end. As your questions come to you, please type them in the chat, and between Kefis and I, we will collate that and make sure that your questions are answered and everybody leaves having exactly what they want. Kefis, thank you for that as well. Everybody, the session will be recorded as well. Just make sure, yes, we're still being recorded. If anybody needs the recording afterwards, that will be available as well. Mary, can I hand over to you?
Yes, thank you very much, Chair. Good afternoon to you all. We're happy to have you here, and we're happy to present this this session. I mean, since the past 6 years, I've been presenting this particular module alone, but this year is spectacular. I think we are 3 that are going to be presenting this module, and I am looking forward to an insightful but also a fascinating time. So just like our chair mentioned, we will present in parts. So we structured sort of you having an overview, a good understanding of what systematic literature review is, and then we go on hands-on to do it on Scopus, on Covidence, and then we will go to synthesizing and reporting. So I will come in the last session, but please feel free. We are 3 presenting, so if you have questions, you could just put it in the chat box. We could be answering those questions, because what we have to teach you in 2 hours is actually something that we should take a day, if not even more, to sort of do it in a better way that you would really comprehend. So we are really going to compress this knowledge, and we hope that you will still get something out of it in the end. If you have questions, put them on the chat box, but we also have allotted some time to answer your questions. Thank you, and I now hand over to Dr. Mbu. He's going to start and take us through the next 30 minutes, and then Dr. Austin will come in with the hands-on, and then I will be back to take the synthesis and the reporting. I put I have, so the technical, could you make them co-host? Yes, I see Mbo is the co-host, but also Austin. And I did upload the slides. Do I have to do it again? Or can you see the shared slides?
Yes, we can see your screen. Could you put it onto presenter mode?
Okay. Is it in the presenter mode now?
Not yet.
Is this what you mean?
Yeah. Yes, it's fine.
All right.
Okay, I guess I should go ahead.
Yes, you can go ahead.
Okay, perfect. Good day, colleagues, and my name is Musongwa, as has already been introduced, and I'm happy to be here with you all. As Doc has mentioned, generally we take some really long time to go through this and try by all means to make sure that these are as practical as possible. However, today we only have 2 hours, and we obviously will focus on the key parts, and hopefully you would be able to get what we're talking about. And at least we do have one session, a session which is going to be a bit more practical. So I will be taking you through the first part of our presentation. Could you please, next slide?
You made the co-host, so I think you could actually press on the slides as you go.
Is it? Okay.
Yes.
Let's see.
No, Mary, because you're sharing, you need to control.
Oh, okay. Okay.
Okay, perfect. Thank you. So today we're going to be learning about a few things concerning evidence synthesis. We will focus mainly on, firstly, we will try to understand the purpose and values of the systematic and evidence reviews and research. We will look at different types of reviews and their purpose and when they need to be used. And we'll also follow the key steps in planning, conducting the different types of systematic reviews. We'll also look at the different tools that have been used by different researchers when conducting systematic reviews, including the Prisma flow charts, as well as the guidelines that the Prisma have really come forth with to help us understand how systematic reviews should be conducted, as well as how they should be reported. And we'd also look at different databases that have been used, and there's quite a number of them. We will also have a bit of information on those ones as well. Next slide, please. Next slide, please.
Okay, I'm trying to press the button and it's sticking. Or should I stop and then you share from your end?
I think that would work best, Mary.
Yeah, because
Would you have it to? Yeah.
the arrows are not moving.
I think that would be better.
Yeah.
Okay. Let me just open mine this side.
Please, you could just type on the
Yes.
chat where you're coming from, so we could just connect. All right, go on, Doug.
Okay. Can you see my slides?
Yes, we can see your slides. Yes.
Okay, thank you. Okay, so we have 3 parts to this presentation. The first two will focus on introductions and as well as the objectives. We'll also look at the overview of different types of reviews. We'll also have part 3 and 4, which looks at how a review should be planned and how the research questions should be formulated. And then from there, we look at the search strategy and the database use in terms of how the databases should be utilized and what keywords should be used, as well as the Boolean or operators. Then the last phase would look at the screening in terms of how data should be screened and who is involved in the screening of them when conducting systematic reviews, and how data is supposed to be extracted using different tools, including Covidence, Ryan, Excel, and etc. So then the sixth session is when we would be focusing on how data is supposed to be synthesized as well as reported. And the last section would look at the common pitfalls and ethical considerations in terms of the selection bias, incomplete search strategies, as well as managing grey literature. So this is quite a comprehensive session, generally, which takes more than a day, but we're trying to condense all that in order to fit to today's session. So before we even move forward, it's very important that we look at the definitions in order to understand what exactly is it that we are talking about. By definition, by definition, what exactly is evidence synthesis? We need to understand that before we even understand the different types of reviews that are forming part of evidence. So evidence synthesis is a process of collecting, evaluating, and combining information from different multiple studies systematically in order to answer a specific question. Systematic and evidence reviews are very crucial for high quality research. They have been used by really very big institutions like the World Health Organization in terms of coming up with guidelines, and a lot of tertiary institutions are actually utilizing systematic reviews, and they are teaching those to students and for synthesizing the data and understanding the research gaps that exist in one's particular research topic. So these types of this type of research is able to help one to consolidate, to appraise, as well as to synthesize the findings from existing studies. They are unlike your traditional literature review. There's a very rigorous methods that needs to be followed in order to reduce bias and improve the reliability. Whenever conducting a systematic review, one of the requirements is that a systematic review has to be replicable. What does it mean? That means that if the methods that you use, if someone else from a different setting is following the very same guidelines that you used, they should be able to find exactly the same outputs that you did find in your review as well. So one of the requirements is that in each step of the process when conducting reviews, you must be able to document what happened at a screening phase, how data was consolidated, how data was extracted from the included studies, and what was the inclusion as well as the exclusion criteria. So this is very important. Okay, so starting from the early 2000s, you can see that quite a number of systematic reviews have been gaining momentum and getting published as well. in the early, in year 2000, about 1,400 systematic reviews were published. But as the years goes by, you can see that there's been an upward trend in terms of publications of these types of reviews. In 2019, close to 30,000, in 2019 alone, close to 30,000 systematic reviews were published in that year alone. So this shows that really there is quite a big appetite out there globally in terms of systematic reviews and other types of reviews that are gaining momentum as well as getting published in different journals. So these types of reviews are also very useful for early career scientists, because you are able to really at least publish even 2 articles from one review. First would be your protocol. You are able to publish a protocol, and also you are able to publish the actual review with that data that's going to be reported in it. So let's look a bit on different types of reviews. Remember, evidence synthesis is the umbrella, and then under it, we would have different types of reviews. A narrative review is what we call a literature review. This type of review has been used by many researchers, early career researchers, and also other researchers. We have all used it when doing our when writing our protocols as well as our thesis. These types of reviews are able to provide a thematic summary as well as interpretation of the existing literature. They are often very selective, though, because generally they would be conducted by just one person, and that obviously introduces bias in terms of what information is included as compared to systematic reviews. So the data quality assessment is not generally required when conducting literature reviews. And also, in terms of trustworthiness and replicability of this type of review, they are ranked very low in terms of trust because they are done by one person. But also, it's very hard to replicate what's been done in a literature review, because sometimes there's quite a number of bias factors that gets to be included. We also have what we call a scoping review. These reviews are the ones that are able to help us to map existing literature on a broad topic or on an emerging area. Their scope is quite broad, especially when you compare it to systematic reviews, and I'll show you later on what I'm talking about. So their scope is quite broad, and there's no requirement for them to conduct a data quality assessment. However, new developments seem to be suggesting that it's important for scoping reviews to also include a quality assessment. So these work differently according to different researchers, but this is not mandatory as compared to systematic reviews. So when conducting a systematic review, you would be required to conduct a data quality assessment. So what is a data quality assessment? This is when you are analyzing the included studies in terms of quality of the methods that were used in order for the researchers to come up with, to be able to answer the research questions. So we also have rapid reviews. These ones are mainly used when time is limited. We've seen quite a number of these types of reviews when during COVID-19, a lot of them were getting published. A lot of rapid reviews in terms of screening as well as database searching can be conducted by just one person. And obviously that involves quite a number of bias, because also you can also conduct a rapid review only focusing on one database. It could be PubMed or whatever database that one could be focusing on. So obviously that limits the quality of the review and the results thereof, especially when you compare it to a systematic review. So we also have systematic reviews. Systematic reviews have been used quite significantly by big institutions in order to answer specific and as well as focus research questions. They are very comprehensive in terms of their search, in terms of how they critique the studies that have been included. They are very replicable, and some of them would be including meta-analysis, some of them will focus on meta-synthesis. So we have what we call a systematic review and meta-analysis. Systematic review and meta-analysis mainly include studies that focus on quantitative data, whereas a systematic review and meta-synthesis are reviews that would include only the qualitative studies in order to answer their research questions. So these ones have been used to guide policy for clinical practice, as well as to answer specific research questions by the different scientists. We also have what we call umbrella reviews. So these ones are review of, otherwise known as review of systematic reviews. Their aim is to summarize findings from different systematic reviews in order to provide a high level of evidence on a particular topic. They are very high level syntheses, and they evaluate the consistency as well as the strength of findings across different reviews. So these ones are generally used when for a high-level summary in order to compare the findings from different reviews and inform broad decision-making. We also have living systematic reviews. These ones, we also saw quite a number of living systematic reviews during COVID-19. They are used mainly when evidence is emerging rapidly, and they may, and if evidence may also change the conclusions. And we saw this happening a lot during COVID-19. So they are continuously updated as new evidence becomes available as well. So let's compare a bit between systematic review as well as a scoping review, specifically focusing on the purpose, on the question type, on the search strategy, on the study selection and quality appraiser. Scoping reviews are generally quite broad in terms of the topic that they explore, as compared to systematic reviews, which are generally aimed at answering a specific question. The question type for scoping reviews is quite open-ended, and for systematic reviews, it's specific as well as focused. Both are very comprehensive in terms of how the search is conducted, but for systematic reviews, then there's a strict inclusion as well as the exclusion criteria, whereas the scoping review can include all relevant literature on the particular topic. So in terms of data quality assessment, scoping reviews, it's not mandatory for one conducting a scoping review to conduct a data assessment, a data quality assessment. Whereas when conducting a systematic review, then you have no choice. It's compulsory for one to conduct this. Scoping reviews can be descriptive or narrative, and the systematic reviews can include meta-analysis as well as or meta-synthesis. And the systematic reviews would provide evidence-based conclusions, whereas scoping reviews would be very helpful for identifying gaps, themes, and trends. Scoping reviews have been used quite significantly when researchers are writing something like your grant proposals to convince the funders that there is a gap in your research topic, and therefore there is a need for them to fund your study. So these ones have been used quite significantly in that purpose. So one can use a scoping review when they need to map the literature, when they need to identify the gaps, as well as to clarify concepts. But also, if one wants to synthesize high-level quality evidence to answer focused questions, then they can use a systematic review. I'm unable to move now. Okay. Can you still see my slides?
Yes.
Okay, perfect. Okay, something has just happened. Yeah, I'm gonna stop and start sharing again.
Can you try taking it off presenter mode and then put it back on presenter mode?
Okay. Let's see. Okay, is that better?
Yep.
Can you
And
put it? Yeah. Sorry.
yeah. Put it back on the slideshow now.
Okay. I can't see my title.
Good afternoon, colleagues.
Can you, yep, try go to slideshow at the top on the orange.
Can you see it now?
We see your PowerPoint, but not the slideshow. Where are you? Can you move up to the orange ribbon on the top and click on slideshow?
Okay, let's start again. I think this should work now. Okay, let me know when you can see now. Yeah, it's moving on my end.
Perfect. Yes, it works.
Okay. It's gone.
Sarah, maybe you should share.
Sorry?
Maybe the technical assistant should share.
Yeah, please, because each time I put it on slideshow, it disappears on my end. Could you please share on your end and let's see if it's gonna work? Yeah, each time I push on.
So I'm pulling it up.
Okay. Is it coming around that side?
Can you see the screen?
1 minute.
Okay.
We can see the screen, but it's not moving.
So Sarah, are you the one sharing the slides?
Yes, I'm going to try to open them on my side and
Okay.
share them.
And Dr. Mbu, can you see anything on the screen?
No, nothing yet. Are you
Maybe
sharing, Sarah?
Oh, not yet.
there's
You've
something on
got
the
your
screen.
slides on.
Oh, okay. Let me. Okay. And now?
Mary, can you upload the slides from your side?
Sarah, if you just give me hosting rights, I can do it now.
Okay. I've only got a PDF version.
Okay, someone is sharing. I think I can see.
So I did start to share, but it's not moving on my side, the
Sarah,
arrow button.
give me hosting rights or share the PDF.
Okay, maybe PDF works. Let's see if it works.
Mary. Can you see that?
Yes.
Okay.
Yes, let's see if
Yeah, I can see that. Okay, seems like it's moving. Okay, perfect. Thank you. You can stop there. Thank you and apologies, colleagues. So there's different stages that one needs to follow whenever conducting reviews. Number one needs to be able to define the research question that you need to be able to answer using the articles that you would have found when doing your search. You also need to define or indicate which databases you're going to be using and how you're going to be screening your data. And I will not talk too much on this because we still have an active engagement that's going to be coming from my colleagues. Also, another stage follows from the screening is what we call data extraction, which is when then you extracting the data from the included studies that would be able to help you answer your research question. Then following that is the data synthesis, where you put together now all your data that you have extracted and presenting them in tables and in graphs in order to make them the data meaningfully explain what you would have found, as well as report writing and dissemination. Next slide, please. Next slide, please. Not moving on your end as well.
Not moving on my end as well.
Is this a Zoom problem or?
Okay, let me try again. Maybe I won't put it on slide presentation, but can you see my PowerPoint?
Not yet.
Yes, I can see. Yes, I can see it.
Okay, perfect. Maybe let me continue from this end, and because I think something happens when I'm putting it on slide presentation. So this is a basic step-by-step formats which one needs to follow when conducting systematic reviews. Let's then move on to briefly discussing how to conceptualize the research question when doing a review. So why is a research question important? A well-defined research question guides the entire review. It tells you what data to look for. It tells you how you're going to extract the data from the included studies. It tells you how you're going to select your articles, as well as what strategy you're going to be using in order to get information that's going to be helpful for you to answer your research question. It also ensures that the review addresses the meaningful gap in the literature, as well as identifying the key concepts and structuring the scope of the study. So there's differences between a scoping review as well as a systematic review research question. For a scoping review, your question would be broad as compared to a systematic review where your question is going to be specific. And I'm going to show an example below. So for your scoping review, your question would be open-ended compared to a very precise and narrow and straight research question that you would use for your systematic review. For example, if you were conducting a scoping review, then one of the questions you may want to ask is what is known in that particular topic that you are interested in. What is known about barriers to HIV PrEP uptake among men in sub-Saharan Africa? However, when you are conducting a systematic review, then you're not going to be asking general questions like what is known in order to get all the evidence. You want to be very specific. What are the effectiveness of PrEP interventions in preventing HIV among men in sub-Saharan Africa, for example? So there's more examples which I would not go all in detail to because of the time that we have. There's many different frameworks that have been used by different researchers when formulating research questions. It's very important for one to be able to use a particular framework that's going to be able to guide your research question. Otherwise, you might be found wanting, not knowing how then which types of studies you're going to be including, what types of data you're going to be including. One of the most used framework for developing research questions in reviews is what we call the PICO framework. The PICO framework, P stands for population. This is when we are looking at what kinds of populations am I interested in analyzing. I stands for intervention. You want to understand what types of interventions are included. Is it PrEP? Is it HIV self-testing? Or whatever the case may be, depending on what your study is focusing on. You also want to compare with alternative interventions, and O stands for outcome. You may want to understand what measures or improvement or effects were observed as a result of the intervention that was conducted. So of late, the PICO comes with an S, which then focuses on study design. Initially, PICO was just PICO ending there, but of late, then they've added the S, which then focuses on study design. Are you interested in qualitative studies? What exactly is the design of the studies that you're interested in? So other frameworks include so the PICO is generally used a lot when one is conducting a systematic review. We also have what we call the PCC. PCC stands for population, concept, and context. And so this one is generally used when one is conducting a scoping review. So I won't also dwell too much on it. I just want you to know the different frameworks that can be useful when you are aiming to conduct a review, and that can be able to guide you in terms of developing your research question. So we also have what we call SPIDER, which has been used for qualitative and mixed methods research, looking at the sample, the phenomenon of interest, the design, the evaluation, as well as the research types. As well as the PEO, which looks at the population, the exposure, as well as the outcomes. So depending on your research question, again, you may decide to use PCC, you may decide to use SPIDER or PEO, whatever seems to fit best with the focus of your review. So we also have what we call SPICE, which stands for setting, perspective, intervention, comparison, as well as evaluation, as well as Eclipse, which looks at expectation, client group, location, impact, professionals in terms of who is involved in delivering the service, as well as what is the service or the intervention that is being studied. So I will not go into too much detail on this, because generally we discuss these also using very practical examples to help people generate their specific research questions. So in terms of planning a systematic review, one of the key requirements is that these must be registered. Prosperio has been used to register systematic reviews, And one of the journals, generally, when you submit your systematic review for publication, they would ask you to provide a registration code to prove that your review has been registered. Prospero is an international database which is used to register systematic review protocols. It registers a protocol before the data it gets to be extracted, and it would provide you with a unique registration number. So one of the benefits for this is that you get to see what other reviews have been conducted, and to avoid duplication and ensure that you're not registering a review that's already been conducted somewhere by other researchers. Otherwise, that would constitute a duplication. So this is very important when conducting a scoping reviews. The database for registering scoping reviews is called Open Science Framework. Also, the same process follows. You have to register your scoping review protocol to Open Science Framework in order to prove that you have gone through the database and checked what other reviews have been published in that particular topics, and also to ensure that you follow the guidelines that are required for one to conduct such types of reviews. So there's benefits for conducting reviews. Is that one of them is that this is free data that you'd be getting out there, and it's already been published. This is work that's already been published by other researchers. So basically, you are using data that's already been published. There's no need to write for ethics approvals and all that. Okay, so again, inclusion and exclusion criteria is one of the most important things that researchers need to pay attention to. We need to be in a position whereby we are able to define what types of studies are going to be included or excluded in our review. And this helps to be transparent, and also helps to reduce the bias, as well as improve reproducibility of your study. However, we do know that there's quite a number of biases when looking at the inclusion and exclusion criteria. For example, if a review is conducted in English, it does not mean that other researchers who may have published their work using other languages are not there. So because I only understand this particular language, therefore there's a potential for bias, because you might find that other researchers who use Portuguese, for example, have published information that could have assisted me in answering my research question. However, due to limitations in understanding that particular language, then that particular study gets to be excluded as a result. So it's very important that one includes diverse stakeholders and collaborators in your review, in order to ensure that you at least minimize the bias that can come as a result of some of these things, and also to make sure that you justify all the decisions and consider all different types of reviews in order to ensure inclusivity and feasibility. So there's also issues or limitations as far as grey literature. There's been talks of grey literature not being able to do a quality appraisal on it, as well as date restrictions. If you are interested in HIV self-testing, for example, you may want to look at studies that were published recently, because self-testing is not something that's been there over the years. So some of these things are very important and key for researchers who are included in a particular review to pay attention to, and to, if there's any limitations, then it's important that one is able to justify and put all the details pertaining to that. So I think next slides I will I'll give to my colleagues who will then take us through a hands-on practical session. Thank you.
Okay. Hello.
We can hear you,
Can you all
Austin.
hear me? Yeah,
Yes.
can you all hear me?
Yes, we can hear you.
Okay, please do allow me to share my screen, as we'll be doing a whole lot of hands-on practical.
And Austin, do you have the co-hosting right?
Yeah, should I give it to him?
Yes, I told you to
Yes,
do the that earlier.
Okay. It's Austin, eh?
Yes.
Okay. Okay, you may go ahead.
Okay. Still showing that host disabled participant sharing screen.
No, even now.
Okay, let me try it again. Okay. Okay, can we all see?
We see it.
Are you seeing it?
Yes. Can you move your mouse around so I can see if it scrolls?
Can you see it now?
Yes.
Okay. So once again, good afternoon. My name is Austin from the University of Pretoria. Essentially, I want to take you through the databases and, of course, hands-on on how to search on the database. But foremost, I want you to realize that systematic and scoping review has gained a lot of attention across different disciplines as a means of rigorous research. And so therefore, in order to streamline our ability to get the data or the articles we really want for either the systematic review or the scoping review, I'd like you to know a thing that every discipline have their own databases that you commonly find the articles relating to the subject area that you would want. And if you look at your slide, for example, you see that in the biomedical, there's what we call PubMed. PubMed is a very wide database. Embase, they are all wide database. Signal is often used by nurses across the world. They are large databases where you can get millions of articles while searching. So the emphasis for this is why you want to go on to search for data, for articles, for your review. It is essential to know the kind of data or the kind of database that you go into. You can, for instance, be in the social sciences or economics or management sciences and be looking forward to PubMed as a means to search your data. So it is good for you to know the right database for you, especially as specify with what the kind of reviews that you want to do. Also, there are multidisciplinary databases like Scopus, Web of Science, Google Scholar, and Sage. There are many more, but these are the ones we have. But for today, for emphasis sake, we'll focus more on Scopus, on the harm-free that we want to do. Also, essentially, there are also specialized databases, for example, like PsychoInfo. The PsychoInfo is usually by psychologists. There's also what we call ERIC. ERIC is Education Resource Information Center. Those who are in the educational line, educational discipline or institute or faculty, they can look forward to ERIC, for instance, as a database to search for articles that they want to use for their review. Also, we have the Institute of Electrical and Electronic Engineer. Essentially, if you're an engineer and of course you are looking for a database to get your article, there you go, you get them. There are also regional databases. There are regional databases. Like in Africa, I think we use most of Agile. There's also the ECOWA database. In Asia, they use the Asian Development database. There's also the Eurostat. Eurostat is also very, very popular database that those in Europe can easily find studies or articles for their review. There's also the Australian Bureau of Statistics. For those in Australia, these are different databases that can be used by the different disciplines to search for their article. Now, having said this, I want us to go back to the hands-free. If you can see my screen, please do let me know. Can you see my screen?
Yes, we see it. We can see it.
Okay. So let's start with the hands-on practical. Now, having identified Scopus as one of the multidisciplinary databases. Now, do we just punch in what we want to search for and expect it to bring out a result, or for the article we need? No, it will not work. So there are some of the details that we may need to know, or we need to have an idea of. For example, there's what we call the Boolean operators. The Boolean operators are mostly words or symbols that are used to combine searches to search for terms or keywords that you maybe are very pertinent to your study, or that you are looking out for in your study. Now, my colleague mentioned earlier before what we call PICO. It is very essential before you go on even to search on database. It is very essential you use, for example, PICO to formulate your research question. I'll give you an instance. Let's say today we want to work on the impact of digital or mobile learning platform on academic performance. The impact of digital or mobile learning platform on academic performance. Please listen, the impact of digital or mobile learning platform on academic performance. For example, in South Africa, since we are doing a systematic review, for example, we can limit it to South Africa. But if you are doing a more broader study, like a scoping review, we can say in the entire Africa or Southern Africa. But how be it, let's work with this topic. For example, using PICO for this instance, you realize that your population is students. That's for the P. For the intervention, we will be looking forward for digital or mobile learning. But for the comparison, maybe you want to compare, for example, digital learning or mobile learning with traditional learning methods. So our comparison will be with traditional learning method. Then, which is, for example, face-to-face classroom experience. Then the outcome will be the academic performance. So let's move on. Now, I mentioned earlier that we have what we call Boolean operators. Boolean operator, like I said, there are words or symbols. Now, what are the words? For example, a Boolean operator, for example, the word of a Boolean operation is this, and. What does this and signifies? The and, of course, combine terms or specify key terms. For example, digital learning platform and student. For example, digital learning platforms and student. Now, look at this. If I click on this search, it may not bring out the expected result. Howbeit, there are some symbols that are necessary for this. One of the symbols is what we call parentheses. Parentheses, if you can see my screen, is like this. It's like more like a bracket. It's not a bracket, but more like a bracket. Now, what does parentheses does? Parentheses is used to order operations. It's used to control other operations. For example, digital learning and student. Look at it this way. Digital learning Please, can you see me? Can you see your screen?
Yes.
Okay. So look at it this way, digital learning and students. So this is one of the Boolean operator. And don't forget, I said it is used to combine terms. It is used to combine terms. So which means, for example, it will search both digital platform and student in the database. Can you see your screen? So it's loading so many studies. There are a lot of studies on digital learning. So it's loaded 7,228 articles. 7,228 articles. Please note this. If you want to, for example, we can add range to our search. We can add range to our search. For example, we can say we want to limit, if you want to shrink, instead of having these 7,228 articles, which may be too large for you to work on, you may decide to use some of the limiters. We call them limiters, some of the limiters. So we may say, for example, Scopus give us articles from 2015 to 2025 to the present. So let's search again. You can see the former was 7,228. Now, because we have added the year, right, it's bringing 6, it has reduced the number of articles. Don't also forget there's a special feature here. You can click here to see, if you want to see how good the article is. For instance, you can click here to see, for example, the newest article, the oldest article, how highly cited are. I mean, of course, you know, the highly cited articles may mean that, of course, it's a very relevant study, especially in this area of our search. Also, of course, the cited by the lowest, how relevant it is. You can search by author, you can search by first author, you can search by first author, or you can search by the article source, that is the journal, and a whole lot that you can do for yourself, just to more like a limiters. But how be it, I want us to note a thing. There are further limiters here. Now, these are subject areas. Now, if your area is not in the area of engineering or mathematics, you may not be interested in this. For example, I may be interested in studies in social sciences all alone. I'll click on social science studies. That's one of the limiters. Then also, I may also want to, what kind of document am I looking out for? Are they article, that is empirical studies? Now, if, for example, like my colleague has stated, if you want to do a meta-analysis, for example, you may be looking forward to empirical studies. If you also want to do maybe a synthesis, meta-synthesis or synthesis analysis, you may also want, for example, you may want to meta-synthesis. You may also want articles. So that automatically take out conference paper, book chapter, conferences, and review. So for example, let's limit our search to articles, only articles. Then, of course, this is our search terms, student learning. Then also, you may be the type that your only or the language that you can tolerate in terms of learning or ability to adapt to is English, which then means that other languages, other articles that are written in other languages, aside from English, which of course might have been determining your inclusion and exclusion criteria, may mean that all of these may not be important or relevant for you. So we are limited to English language. Now, having said this, I will set out to limit. So it's going to refine, the system is going to, the database is going to refine the study, the article that is going to bring for us. So it's loading. So it has loaded from about 6,000 something to about 1,888. So this is how we keep shrinking to know all of what we want in terms of our search engine. There's also what we call or that's one of the Boolean operator. The or is used to expand your searches. For example, you may want to search for students or academic performance. The search engine will bring articles about either student and academic performance. Don't forget, the and we bring these two together. But in the case of this, for example, let me show you this. In the case of this or, it will bring either of the two in any article. The previous one, and it brings any article that combines the two. But this one, it will broaden your search. So we are likely to have more articles coming on. So it's loading. So let's see the number of articles that we get, because we are expanding our search using or is used to expand searches. You can see about 53,000. The previous one we used and it was about 8,000. So all of these terminology are very, very important. All of these words are symbols that are very, very important. Having said it, there's also not. Now, if we are talking about digital learning platform and student, for example, do we want to include all students? We might want to limit our study, since it's a systematic review, to just undergraduate students. So we might say not postgraduates. It's just to tell you that the not there is to exclude study. Any study you don't want excluded there. So whatever searches or article that is going to bring forward, you are more okay. So you can imagine 140 articles from over 51,000. This is just to tell you that it is used to exclude some of the search time that you may not be interested in. We are only interested in undergraduate students, not particularly know that. So there are other things that are added, like for example, we can also add quotation marks. What are quotation marks used for? Quotation marks are used to search for exact phrase. For example, using this quotation mark, it's going to bring studies that talks about exact word, digital learning platform or student. That's what quotation mark do for you. Also, there's what we call asterisk. Asterisk, or sometimes is one of the wide cards in database words. Wide card. What wide card does is, for example, we have mentioned that we are talking about students. This is it, wide card, student. Now, what this wildcard does for you is that it ensures that every other word relating to student is going to synthesize them and bring them all together for you in the search engine. For example, what I meant is this. We are looking out for student, but it's going to bring words such or article that talks about undergraduate students, they are students as well. It's going to talk about college students, they are also students as well. It's going to talk about postgraduate students, they are also students as well. It might as well even talk about elementary school students. So it talks about student is the word, so but it expands it. It's more like it brings about variations of the word that you're looking for. Student is the word, but it's going to bring about variations of the different students that are available. In order not to waste our time, once you find a study, or once you find study that you are looking out for, like we did the first time, you can easily export them. You can easily export them depending on where you are exporting them to. For example, if you're exporting them to Excel, you use the CSV file document. So you click, for example, we want to export all of these documents, about 140 documents, for example, to further our screening and extraction. Once you click on all, it will click on all the studies that are showing for further screening. You can see the orange tick in the boxes. Thereafter, you may want to export. Now, this CSV, it's for it to allow you for to use Excel to do your further screening. But I won't be using that. I will use RRS. RRS is a research information system. Now, this, of course, like we want to use confidence, and this will allow us to use confidence as it were. Now, let's go back. Let's go to our confidence. Quickly, let's go to our confidence. Now, fortunately, we are going to use a demo. We are going to use a demo confidence. As I would like us to make this as practical as possible. Please let us make this as practical as possible. This is confidence. Confidence is used for reviews. For reviews, generally can accommodate different types of review, and it synthesize your review in a way that make it scientific, more scientific than the manual method that you want to. You can see once you register, once you click on confidence on your Google search, once you click on confidence, for example, so you click on free trial. So in the free trial, you punch in your name, your last name, the email you want to use, and your password. It will ask you, can see I have registered with so many mail. I've registered with so many mails, so I may not be able to register again. Your password will ask what role best define you. Are you a student? Are you a librarian, researcher, or whatever you are? Of course, you expect to see them. Are you affiliated to any organizations? What is your
Austin,
department? What?
Yes. Scopus is still what people are seeing.
Oh.
Yes, so you need to stop sharing and then share the confidence.
Okay. Thank you for this. Okay, so please, can we see?
Yes.
Okay, so like I was trying to explain, these are the for demo account. These are all what you need. It's free. At least it can accommodate about 500 articles for you to screen for free. And so these are all what you need. Type in your information, and once you click on create account and send a link to your email that you have registered in here for confirmation. Once you have confirmed, it takes you to a place like this. Yes, start a new review. Now, please, we may, because of our time, we may not be able to go much far. Plus, I would like you to listen to every details on this. Please do understand this. As you're starting a new a review on the confidence, please do understand that you are not doing a Cochrane review. A Cochrane review is a kind of review that is used in the medical sciences. So we are not doing that. That's why I already click no. So what is the name? For example, what is the name of study? The study we plan on doing. If you remember, I said the impact of digital mobile learning platform. On academic performance. So once you do that, it will take you to the next question. What type of review are you doing? Is it a systematic review, scoping review? Like my other colleague have stated, any kind of review that you want to do, scoping review, confidence accommodate those kind of review. The difference is that as you move on in the review proper, you realize that there are different interface to all of these reviewed different types of review. The scoping review is more broader. It's more broader in this regard. Also, you type your question. Now, what kind of intervention? You know, systematic review is tailored towards intervention study. What kind of intervention are you doing? If you are in the medical sciences, you may pick any of those diagnoses and on the like. But for us, for example, in the humanities or education, management sciences, I may choose qualitative, or you may choose other, and of course, to ask you what kind of area are you looking for. So for example, I may type, for example, management science. Now it asks, what is your area of studies? What is your area of studies? For example, I may choose this, then say create. You create. So it takes you here. So one of the first things that you will need to do, please do understand that systematic review is not a thing that an individual alone can do. You may need additional person to review along with you to minimize biases. There are chances there will be a lot of biases when you alone want to engage in systematic review. Generally, not just using confidence. There are a lot of biases that may occur. So in order to make it more scientific, you may need to invite another person. You invite another person, type in their name, their email, and so immediately, the person will receive an email inviting them for a review. Once you have done that, the next thing is to set team settings. Team settings. Now, this team settings, just to say, the person you have invited, how do you want you and the person to go on with the review process? Now, there are a lot of rules that may be involved in the team settings. And so, you need to allow everyone, that is either you or the person you are inviting for review, to have the power, the ability to change certain things as the review is going on. If you be the only one to manage review, it will show. So you have to choose the person you want to be the one to manage review, especially when there are conflicts in the process of screening. There could be conflict, for example, if you agree with a study and the person reviewing with you do not agree with that study to be included in the study. So there may be conflicts, and there will be need to have a common ground where one of you, for example, like you have said in this setting, will have to resolve the conflict. But let everyone have the ability to do that. And so this also entails with the full text. It also entails with the extraction as well. Now you move on to the eligibility criteria. Now the eligibility criteria, do not forget, I keep referring to PICOs. Now, for example, you can see if you want to maybe the PICO framework, the confidence will lead you to it, and of course you understand this is how it's being done. But because of our time, you need to understand that your research question, for example, must be framed in a way that reflects PICO. Like I've mentioned to you, previously I've told you, even while we're in this database, that, for example, our PICO, given our topic, for example, our P And then the student. What kind of student do we want? Undergraduate student. Undergraduate student. What is our exclusion criteria in terms of our population? We are not interested in postgraduate students. Also, we may not be interested in we may not be interested in non-students. Non-students, they are not part of our population. So also, what is our intervention? Our intervention is digital learning. Digital learning. Digital learning. Digital learning. Then what is our exclusion criteria in terms of digital learning? Maybe all other non-digital learning. Non-digital learning. Non-digital learning. Please do understand that because of our time, there are more that I can populate in these boxes. But because of our time, I just want to show us an example so that I can upload and of course even screen. For example, I will screen an article so we can see. What is our comparator? Yeah, what are we comparing digital learning to? Traditional learning method. Traditional learning method. Other methods aside traditional learning. That is our exclusion. Now, what is our outcome? Our outcome is academic performance. We want to see, for example, how digital learning, which is our intervention, how it affects student academic performance. So, academic performance. We can add a lot of things: academic success, awards, exams, scores. These are more. So in our exclusion, non-academic performance. So what are the study characteristics? Young adult, for example, can formulate, since it is expected that undergraduate student may likely be young adult. So young adult may be, so older adults is our exclusion criteria here, older adult. Now, these are some of it, so you save it thereafter. All of these are other things that you think are important to the study that you also want to find out. So we save, and once we save, we go back to this and import. Please look at this. We import our references. The references I saved the other time, we import our references. Please do understand that at any point that you feel confused or you need any lessons, you can go to this place, this help. You can explore, Confident itself. It will give you an array of different, if you want to watch webinars, there are webinars you can watch on so many aspects of Confident. Every step-by-step stage of Confident, you can easily do that. So let me quickly import some of these things I've said. So don't forget, this is just one. You are meant to search other databases to ensure that you search other databases to ensure that you have a lot of studies to populate your this platform so that it can give you wide arrays of options. So you screen. You want to screen. The first thing to do is screen. We are not going to do full text in this context. We want to screen foremost. And what is your source? You look for, I've mentioned these are the different databases that I've mentioned to you earlier on. So since our import is through Scopus, the one we save, so I click on Scopus. So I can choose file. So it will take me to wherever I've saved it. let me look for, okay. So look at it this way, digital. I labeled it digital. So it has been imported. So you can see. So I screened what we said the other time to about 12 studies. So you can see this is about 12 studies. 12 studies. So yourself and the reviewer that you have invited, you need to follow up the person so that the person will do the same thing as you're doing. So what title and abstract screening entails in this regard is you go through the abstract to see if the study has some of the component of what you are looking at for your own study. So let's click on, for example, continue. Once you have clicked on continue, you can see it's bringing out different option of voting. It's bringing out different option of voting. You may vote no to the abstract. When you vote no, it automatically take out the study. You may vote maybe we put the study in a place where you and the other reviewer can deliberate on whether to add the study or not to add the study based on what some of the keywords that you are looking out for in the studies that you have uploaded. So once you vote yes, it moves to full text. So for example, look at it this way. You need to read the study. These studies talk about remote learning during COVID-19 pandemic and the likes. Let's say, for example, we are interested in this study, so I will vote yes. So once I vote yes, it automatically moves to full screening. And so you can see these are all others. The other person, the other reviewer may also need to vote. Now you may also apply your filter. Since we are still at the title and abstract, we apply our filter to see if we want to know the author, if it is everything you want to see about the studies, especially if it has been uploaded. Then you also, please don't forget, you also have your criteria. You can look at your criteria again to see if the study you want to review the abstract matches up with your study criteria. You can see these are the criteria we did earlier on. Now, once that has been done, once you have successfully screened the study to full text, it will appear here. It appears here. Here is where you can screen all your studies. That's confidence will import the full study that are open access, while you may need to import those ones that do not have full access. You get it yourself through maybe your different libraries. Because of our timing, I may need to stop here so that Dr. Mary may have to continue. Thank you.
And Austin, I can give you some more time because mine is just to explain how this would be reported. So I think people might be more interested in, and I see also some questions at the chat button. So I can give you some more time to finish up if there's something more that you
okay,
need.
So that's fine.
Yeah, I can give you up to 15 minutes. I think I should be able to wrap up my session quickly.
Okay, that's fine. That's fine. Please, can you see my shared?
It's coming up. And Mary, will we have at least 5 minutes at the end? So 10 minutes for you and then 5 just to address the questions?
No problem.
Okay.
Okay, so once we have successfully screened, can you see my screen, please?
Yes.
Yes.
Yeah. Oh, okay, so please, so I can go on. Yeah, please, I know there are a lot of questions because of the time you have to rush through some of these things. Actually, confidence, each part of confidence, like you can see, these are different parts. Aside from the settings, this setting, each of the different parts from importing of reference, it needs a day to explain fully what it can do, what it entails. So a day for imports of reference, a day for title and abstract screening, There are a lot of explanation around it, but I'm just trying to rush through. Essentially, this is where the bulk of the work comes in: full text and extraction. This full text, the extraction itself, is a whole lot. Extraction can be further divided into different parts, and that will take a lot of it. But in terms of the full study, for example, this is how it comes. I had to include the study. So what it does is it asks you, if one's confidence cannot find an open access, if confidence do not have, is the document rather, or the article is not an open access document, it means that confidence may not be able to upload it for you. However, if it is an open access article, confident, as at the time you are screening to full text, confident will locate wherever the study, the article is, and upload it for you already here. Howbeit, if it's not an open access, then you may need to upload the studies yourself. Please take note. If the study is not accessible anywhere online, you may need to contact your library, your school library. There's an interlibrary learning of materials. Once they cannot get it from you, you may need to exclude the study. Exclude the study. So in this area where my cursor is, there are about 3 items there. It will show, for example, if you could include the study, exclude the study. If you are going to exclude the study, like for this, I have excluded this study, you have to show the reason. See my reason. The reason is that the full text is not available. I may not be able to wait for a long period of time in order to search for this. And so therefore, I may need to move on with other studies that I have. So in terms of uploading, you have to click here. You can see, if you can see my screen very well, you can minimize this and drag your document to here, it will fill. Otherwise, you download from the platform. For example, let me give you an example. Maybe this is the document, for example, and I click on it, I will upload it. It will show you that it is uploading. And once you are done, it brings you to this finish button. You click on finish. And so you can see it's saying full text uploaded by me. And so it's possible that your co-reviewer is also the one that uploaded the study. It will also show here that it's uploaded by the study. Like I've said before, it is confident that I've uploaded the study. It will also show you that the confident also uploaded the study. Now, the next step is for you to review the articles. You review the articles. Now, so here's where the bulk of the work comes in. You have to read from A to Z. If you don't read it now, I know so many people may not be, this may be too long process for them to read all articles that they have included in the study. Yes, it may be, but then you have to, because if you don't read it at this level of full screening or full text screening, you have to do it at the level of extraction, because all of what you'll be extracting from this study for your own study, right, it may need for you to have a rapt understanding of what you have read here. So you have to read the article from A to Z. For example, starting from the introduction. Is the aim actually stated? If the aim is stated, did they adopt any theoretical framework? What is their research question? Now, when you go to methodology, you want to see their methodology. So see their research question here, for example. You want to go to methodology. What is the design that they have used? All of these are important. Now, once you do this for all the studies that you have imported, that you have included, that you have screened from abstract and title to full text. Now, having done that, you move to the extraction review. Now, this extraction is is a bit technical and more rigorous. Now, let me click on extraction. Now, look at the study. I'm extracting a study already. You can see, say 2 hours ago. Now, let us go through proper extraction. Now, before you go through extraction, please, you can see these 2 items here. They are very important. They are sacrosanct to the study, to your review. As a matter of fact, your review is not complete or cannot be completed without these 2 items: data extraction template, quality assessment template. Now, clicking on data extraction template, it will bring you to this. Please do understand that I already filled this. Now, there are 2 things to read. Understand this. Now, Covidence will bring their own template for you. You may not be that too okay with confident template, so you reset the template. Let me reset. You can see you reset the template, and you start adding your own information. For example, I may add general information. As a if you want it as a subheading, you create it there. If you want it to create a single choice or multiple choice that you can, for example, look at it this way. Maybe, for example, I want to see the methodology used or research design used. For example, research design used. I can type the option. The option, for example, comes with, for example, maybe cross-sectional research design. If you have used a mixed method, for example, it may be very good for you to use sequential design. You can also, the population of the study, the procedure of the study, all of these are very, very important. These are all what you do. Please don't forget, as you're doing all of this, make sure you save them. Make sure you save them. And eventually, when you are done with everything, then you populate. See all what I've done. Look at it here. It's here. So it's here. So you publish everything. So you go back. It will take you back. Also, this quality assessment. Quality assessment is also how genuine is the study, how original is the study. Now, please, Confidence will give you their own templates. They'll give you their own template. But over time, I've never used the template from Confidence. So what I use for me is the MMAT, Mixed Method Appraiser Tool. The Mixed Method Appraiser tools allow you for your study is a qualitative study, if it is a scoping review, if it is a quantitative review, if it is RCT, if it's not RCT, the appraiser is encompassing. So for this instance, I've used the MMTA guideline or template, and so you can see. So, what was there a clear aim of the research? Yes or no? Now, when we go back to when I want to extract the data, you have to tell us if you are picking any of these choices, whether yes or no. You will tell us why you are picking the choices. The adoption methodology, is this suitable to answer the research aim? That is the adopted methodology. Can we say that the methodology that the researcher adopted for the study, is this suitable for the aim? You have to tell us if it is. The research, is it appropriate? The research design, is it appropriate? the research instrument and recruitment strategy of the participant, is it also fine? Are the findings adequately derived from the data they showed or they published? Is the result interpretation sufficient? Once you have done that, you go back and start the extraction proper. You can see to tell you begin extraction. Begin extraction. So, I mean, they bring the study here. So you have here on your right side, the extraction, the data extraction, all of the questions that you have asked in the extraction template and the quality assessment template as against the article, the full article. So like that's what I said, you need to read the article, you need to have read the article to have a proper grasp of the article. So as you're doing this may not take you more time, you may not need to reread everything. So bulk of what it is that you ask them, the general information, for example, if you have asked, is the aim of the study, what is the aim of the study? You pick the aim of the study, you can copy and paste. For example, look at it here, you copy and paste and put it here. And so that's how you do it. In terms of quality assessment as well, as you're doing that one, you also do this. So was there a clear aim of the research? I'm picking yes. It's going to ask you supporting your text. Why are you picking yes? You need to tell us why you think the aim of the study, there's a clear aim of the research. And please, as you're doing this, the other person, the other reviewer at the other end is also doing the same thing. At the end, you send it for a consensus. Sending for a consensus means that you want to compare what both of you have done. And of course, if there are conflicts, it can be resolved. If there are no conflicts, it moves to exportation, data exportation. And here you go, you export your data. You can see your extraction, the extraction data. You can extract only the consensus alone. The consensus means that both yourself and the other reviewer, what you have done, the extraction you have done, is it the quality assessment alone? Whatever, is it all the data that you have in there that you want extracted or exported? It will do that. Thank you very much.
Okay, Austin, did you see some of the questions, especially on, or can we do that later on?
Yeah, let's do that later on, I guess.
Right. Thank you for your time, and thank you for hanging. Let me upload the slides. Can you see my screen?
Yes, yes.
Okay.
Can you close the bar on the left, all tools, Mary?
Oh, did I upload
Yeah, you've got the PDF open.
the PDF? Okay, let's see if it works, then it's fine. Right, so thank you for your time and thank you for hanging on. And we're so sorry, this really requires a lot of time. The hands-on, I think for me, it's quite crucial for you to sort of have a feel of what, how you can do systematic literature review or any synthesis of evidence. And Austin has done this quite often. We've done a number of articles from this Covidence, and I'll be sharing some of the results from the reviews that we did. And Austin is my my postdoc, and we've been working quite a lot in doing systematic literature review. And I always tell researchers, whether you're a PhD, and I think for PhD, I would really encourage you to get your hands on doing systematic review, or just get yourself in a position where you know the literature of where you're going to do your research. And when you do this rigorous work, you actually can publish that work, and it's already putting you at a position where you can be referred to, and people will come looking for that very one article that you published using a systematic literature review. So quickly, I just want to run through how you could synthesize. So we'll sort of look at what you're looking for, especially as Austin mentioned, your research questions would guide you on whether you will be looking at descriptives during your sentences, or you would want to go further to even do some meta-analysis from your project, or from the review that you would do. Very important, you need a Prisma flowchart. I did put the links to Scopus, to Covidence, and to the Prisma flowchart. These are very important. I mean, it's important that you have it, because it would guide how you're reporting, and it should be systematic. Umpo mentioned that you need to get to a point where anyone can replicate what you're doing. And so a way to report this, and many journals would want to see that you reported, this Prisma flowchart. So this is a Prisma flowchart, and it has all the database you've consulted, how you did reduce the articles. You would see that Scopus was just one of the database that could be used. Science Direct, depending on what field you are and what research you're doing. And then you want to go further to remove any duplications, you would indicate that. You need to show info methodology session as one of the critical sessions in doing a systematic or evidence review. You need to show the records. So it's a template. It's just tells you what to report and how you report that. So just for me to be quick, I think there was already emphasis or some explanation about the inclusion and exclusion criteria. And you would do that. Many of the platforms would give you the opportunity to include and exclude, I think, but Scopus does that in a more systematic way. So I would not take time here because of our time, but you need to know that whatever you're not including, you should also report in your methodology session. Whatever you include, you should always motivate for whatever action that you are taking. So one of the summary tables you would want to have from your study is this one. But also depending on the study and the question you're asking. So you should be able to get to detailed, even if this would be in your appendix, but you should have a clear detail of where this countries, where the studies are, what kind of study, the sample population, if that is necessary in your study. But this is sort of what you should want to present based on how you are approaching the question, because then it just gives a quick summary of the articles that you used in your review and some of the key elements or characteristics of that article. Are you looking at the methods? Is your question related to that? And therefore you need to know. So for instance, if it's a study in public administration where I am and I want to know over time in maybe a particular sub area in public administration, for instance, co-creation or co-production, I want to check if the studies that has been conducted in co-production or co-creation includes surveys, or it includes any quantitative method, or are they just qualitative case study? So then this table should indicate the kind of methods, research methods, or even the findings, or the where the studies are. Some of the you could actually present your result in this manner, just to show a pictorial. I think it does well when you're able to show such pictorial and then also explain this. You could also sort of present the studies and the method in this manner. This is also from one of the study that Austin did run that we're trying to publish at the moment. And also, if it's important that you show the region and the province and how your studies is indicative of presenting the results, and then trying to identify that this province are in particular either. So in this case, we're looking at whether there are a number of crime issues in these provinces, and that's why we're presenting this result in this way. So let me quickly, a systematic review is actually a full publication. It's an article, so it would contain all the elements of an article. You would have your abstract, introduction, method, result, discussion, and even your recommendation. So all the elements in the paper would also be in your research. I think one of the critical thing you want to pay attention is the ethical consideration. Ethics is quite important for every research. I think for us at UP, whether you're collecting data in the field or you're going to be using secondary data, you would have to do some ethics application for that. So I think one of the key elements, I would say, is transparency, reproductivity, because you might get to the end of your paper being accepted, and then and the publishers are asking for the protocol you use. They're asking for how you did the documentation, especially if your methodology is not well explained, is not clear, and there's doubt being cast on the work you've done. You be sure that they would want to maybe request that you provide access to how you did conduct this your studies. So it's important that you make sure you do the search well, because if it's not, then it would not give you the right, or it will exclude certain certain studies that should be in the work. So your selection criteria, you need to think around it very well. We saw Austin mentioned the and all. You see how important that is. Those Boolean words are to your research, where you're supposed to put and you put or. It might not get you the required documents or articles that or publications that should then come up. I would managing gray literature. I would say if you're doing a systematic review and you're targeting a good journal, a top quality ranking journal, you probably want to avoid gray literature. That would be my advice, because those articles might not have gone through peer review, and for any quality journal, they probably would want to pay attention. But if you're doing scoping narrative, maybe that you would want to give it use this or give that a consideration. So selection bias is something that is possible, because whatever there's a lot of subjectivity. It's a qualitative process, especially from the beginning, and it's very important that you pay attention to the selection criteria that you're using. So the risks of excluding relevant studies due to narrow inclusion criteria or unintentional auto bias is real, and you want to pay attention to that. And that's maybe most probably why you should do this study together with, just invite someone, and I guess the reward for doing that would be that the person is a co-author in that publication. Skewed result if the study's population or outcomes are not well represented. So those are quite issues you want to look at. Make sure that your search is well it's well thought of. When you fail to search multiple database or use comprehensive keywords, it is not going to give you the right articles or publications that need to come out. So ignoring unpublished or non-English studies will limit your findings. But of course, if you do not understand that the language, you probably want to avoid adding that, and you could explain why you exclude that. I mean, for every studies we do, there are limitations to them, and those are things you could actually report. And I think for me, being a reviewer also of international, editor, but also I do review for many journals. but being an editor of an international journal, I think we pay attention to whether or not the authors are just trying to tell us all the nice stories, or are they also interested in, owning up to any kind of limitations. So I would think it's a strength when you put out your limitations in your studies, rather than wanting to shy away from it, or just keep it away. I would emphasize ignoring unpublished work, especially if you're targeting good journals. Ethical consideration: avoid cherry picking studies to support a preferred outcome, but also give credit to whatever studies that you are referring to, and make sure that in areas where there are conflict of interest, you make sure you disclose that, and then ensure that if the study is funded, because I know there are such studies that are also funded, you make sure you report that. And of course, if there are any conflicts of interest with the funders, you want to also report that. Many journals would ask for you to indicate that as a statement. An ethical justification: it's also very important that you want to include that. If you have co-authors who understand other language, and you want to include that. If not, then let it be a limitation of your studies. Unfortunately, I have to rush this because of our time, and I think we're already 3 minutes on the hour.
Okay.
I would want to hand over now to our chair. Thank you.
Thank you. Thank you so much, Mary. Thank you, Austin and Boo, as well. Looking at the group, we still have 100 people, so I want to thank everyone for hanging on, taking that as an indication of the usefulness and value of the session. We are recording the session, so it will be available for you to download if you need to leave. I want to try and just take 2 minutes of our presenters' time. What I'm going to do is I'm going to post in the chat all of the different smaller questions. And if I could ask Boo and Austin, if you could just look at that and respond to it in the chat. And then Mary, if I could just ask you to respond to this one bigger question, and then we'll close off for everybody. And the question is, can you just give us a little 2-minute view on how to carry out risk of bias assessments? And do you need to do this for every systematic review? If you're answering, you're on mute, Mary. Mary, can you hear me? Or Dr. Mbu, Austin, if you want to jump in on that question.
Okay. Which question is that?
Could you just give us your view on how to carry out risk of bias assessments, and must this be done for every systematic review?
Okay. My take on that, especially when conducting a systematic review, you obviously want to be conducting a risk of bias. And there's different tools, honestly, that have been used depending on the type of review that we are doing. For example, we have what we call the Cochrane risk of bias, which focuses on control or randomized controlled trials. We also have a risk of bias in randomized studies, We have JBI. These guys are based in Australia, and they develop guidelines for how systematic reviews would the quality assessment should be conducted. And so they also have specific tools depending on your research questions and so forth, and the type of review that you are doing. So it is a requirement that we must do this phase, but also there's different tools that are allocated depending on what kind of a review that we are doing.
Thank you. Just lastly, just before you leave, if you can complete the evaluation form, it's a generic one, so you complete the same one for each module that you attend. The link is in the chat, and I'd like to thank everyone for attending today. I hope you found this useful. I hope it was what you were looking to learn and to engage with. Thank you again to our presenters. It was really intensive and very valuable. Thank you. Yes, we needed more time. We'll schedule that for next year's session.
Hi, did you talk about the evaluation, please?